Hey Chris, how's it going? We're just getting started over here, making sure my sound is good, not fake a mirror. How's it going? Sundays, we take Sundays a little more seriously than other days because we do labs on Sundays. So we're going to do some labs today. Labs are always fun. We'll give it a minute for people to show up and we'll get going. Get my water bottles out here. All right. Traffic Kings here. Hey, over on the YouTube side. Nice. All right. So let me pull this up here. I got my notes all up today. I figured we'd actually do some labs and then go into looking at some of the information about the service and all that. So hopefully you find some stuff that's useful. Hey Boris, how's it going? So we'll start out with, for people that haven't been here on like a typical Sunday, we kind of just go through labs, and I'm trying to make it a little more, let's say, streamlined. So we're going to drop right into the labs. We're not going to spend a lot of time talking about it. I will link this over to the people that want to do it, and anybody that wants to follow along with me can hop in the labs with me and do them. And then I've got questions over here on the right. I always tell you guys, like, pop open a notepad plus plus, Obsidian, some type of markdown editor. I don't care what you use. Just get something to take notes for yourself, right? Because you will remember things better if you take notes. If you just sit around and hang out and watch me do stuff, there might be some value in it. But if you actually do the stuff and touch it and understand it, I think you're going to get a lot more out of at least hanging out with me here. So, all right. So we're doing an NFS lab. And it says right here, set up the NFS share from node 01. And here's our scenario. Your team has determined they need an NFS share to facilitate file system access across multiple servers from one central location. Now, sometimes I hear people talk about NFS and they're like, it's not as efficient and this as some of these other tools. And yeah, that's true. There's other tools that can do the same thing, but they're almost overkill in a lot of cases. I mean, if you just need to share some configuration files that all your systems need to get to, if you just need to share flat files that don't change much, NFS is great for that. It really is. Is it your back end data source, and is it where you're going to be running databases out of? Absolutely not. That's not what we use NFS for. But NFS still has its place in the industry. In fact, I would say, like, rough estimate, just guessing, 85% of maybe all Linux systems I've ever worked with have some type of NFS to somewhere, some central store somewhere, right? So we're going to set it up, and we're going to deploy NFS on node 01. So node 01 is going to become, in our minds here now, the server, and then control plane is going to be the client. That's what it says we're doing here. So share a file system out and then verify that it's working. Okay? So let's go do it real quick. We'll SSH over to node 01. We need to know how to do that. And we'll verify that there's no NFS on that other node. So how do we verify, not installed? Or is it installed, right? That command is simple. It's dpkg-l grep for name of package. I'm just putting this in my notes over here. Now, NFS is what we're looking for here, and dpkg is the way we do it in our Ubuntu style systems, but on Red Hat we use rpm-qa, right? It's a pretty simple little thing to switch between it. Where are my teeth? How's it going? Hopefully, I'm just trying to streamline the labs a little bit and show you guys that you can go in here and figure this stuff out. I've got my notes over here, so hopefully this is useful to some of you guys that want to maybe step your sysadmin type game up. So let's install the NFS kernel server, and then we'll go ahead and have that installed. And it's going and it's setting up a bunch of symlinks and some other stuff. But what other ways, besides just checking the packages, might we check to see if something's installed, even if it's not yet running. Like we're still not even to running yet. What if I did something like systemctl status NFS or NFSD? Oh, you know what? It might not. Hold on. Let's look. I don't know what it's called in Debian. Ah, it's NFS server. All right. So maybe is it installed could be something like just seeing if it's set up systemctl grep for name of package. Now, for some of you guys that are getting into the space or don't yet work there in tech, you'll often see engineers do this where they'll say like name of package or something, and it just means to drop the value in there. And I have to show this to college students a lot, so I'm going to show it to you guys. You also take the less than and greater than sign off as you, right? This is a less than sign here. This is a greater than sign. And you take those off as well. Those are part of the variable name interpolation that gets dropped in, right? So, okay, there we go. Alex, yeah, hopefully this stuff's useful to you. Yeah, if you bought the book, that's cool. This stuff is the same type of stuff. I'm just looking at it a different way. So these are some of the labs from the book right here as well. The labs are all free on Killer Coda, guys. Anybody can go do the labs. The book just adds a little bit of color to it, I think. All right, so we've got it there. And then how would we check to see if it's running? Well, here's a whole bunch of commands right here that are just part of the system here. But by the way, you're looking at my notes over here on the right that I'm just doing for each of the labs today. And if you think about it, it's just like all that stuff we've been talking about with, what's it called? The Socratic method. I'm just asking myself, can I check if a service is installed? Can I check if it's running? And if I can't do those things, I need to work on understanding those things, right? I need to just kind of, so is the book, so is it running? Systemctl status name of service, right? That's what the command is there. Is it running? And ss-ntulp, and then grep for maybe the known port number, right? So if I know the port number, but what if I didn't know the port number was 2049? What if I didn't know that? How might I figure that out? Well, I might be able to grep 2049 from Etsy services, and it might tell me some information that my system knows. So this might be, as we're going to look it up, grep NFS, or in this case, name of service from Etsy services. So in this case, that would have been grep NFS Etsy services, right? So we could see then that NFS is 2049, right? So now I see that that's kind of working, and that's kind of good. And I say, notice the service running, the port's open, and oh, it's TCP. So if I didn't know that it was TCP, it's TCP, but it also can listen on UDP. So you can use TCP or UDP connections for it. And then we can also verify that the firewall's not on. Okay, the firewall's not on. We should see that that's inactive. Now, this is a little bit of an aside, but also for people who are going to spend time in systems and want to understand it. This firewall status is inactive, but is the firewall service running? This is kind of a bit of a side. Systemctl status UFW. The UFW service is active. Like the uncomplicated firewall is ready to run in our system. We're just not, it's not doing anything. It's inactive. So if somebody were to ask you, is the process or is the service for the uncomplicated firewall running and enabled, the answer to that's true in this system. Is it doing anything in this system? Is absolutely not. And those are two kind of distinct things. And this also comes into sometimes when you're dealing with compliance. Guys, all right, I'm going to tell you something that maybe isn't, security teams are going to be mad for a second, but it's true. If the rule simply says a firewall must be on, we are following the rule right here. We are following the letter of the law, right? We are technically correct, the best type of correct, but we are not actually doing anything with it. So the question was, what's the difference between UFW and firewall command? Well, so since this is an Ubuntu style system in the lab that we have here, the uncomplicated firewall interacts with, this is actually its own service here, whereas Firewall D, which is over on your Red Hat style systems, that is just a front end wrapper for your NF tables instead of IP tables. They're NF tables, and it's just a different service. Tomio or Tomio. Okay, so why is it running? Yes, and then we say, well, where do we configure it, right? So in this case, we're going to make a directory share, and we're going to give it some file system permissions so that we can allow people to write from remote and all that kind of stuff. And then we're going to add a line to Etsy exports. I'm going to hit Shift G to go to the bottom. I'm going to hit O, and I'm going to add this line right here. And just grab this line and copy it. Paste. Boom. All right, so where is it configured? Well, seems to me to be configured in Etsy exports, and that is going to be our actual shares, right? And then where's it configured to start is going to be systemd. And if we want to find that service, we can find that service. Let's go ahead and write this out. And then if we want to find the service, systemctl cat nfs-server, right? And we would see that this is where that service is. So systemd service, systemctl cat, and then service, name of service. And then that would show us where it's configured. And in our case, it's this lib systemd system nfs-server.service. And then here's how this was actually called when the system was started. This is the actual command. It did a check, and then it actually called this command to start the service. All right, so there you go. And then after you make a change, this is an important thing. The important thing is I don't know what I was going to do there, but after you make any change in a Linux system, and this was a design decision made long ago, and it's the right decision. Just because you made a change to that file does not mean that file is being read in real time. So Etsy exports is never going to show that those things are actually sharing anything out. So let me go ask right here too. Is it sharing? And that's going to be show mount -e. It'll show you if it's doing that. Anyways, where I'm going with that is right here. Why, if you think about it, why would it be smart if you have a service running to not have that service automatically going back and checking its config file and rereading its config file in real time? Does anybody know? If you just sit around and think about this for a little bit, I've told it before on stream, so it's not like some big surprise, but it's important to understand. This is the same. This is actually, funny enough, it's the same reason that journaled file systems exist. It's the same exact reason. So why might we not want something, if I'm editing a file, to be coming back and reading that file in real time? Why do we only want it to read the file when we're all done? Anybody know why? It's the same exact reason why journaling exists in file systems. It's the same problem that's caused. Does anybody know? Think you guys that have been around know. I've said it before on stream a lot. Let's restart that service, and then we'll show mount -e, and then there it is. Now we see that share actually running on the system, but we didn't. Just because we put it in Etsy exports does not mean it was reread. Well, here's why. Manual control is part of it, but it's actually, we don't want the system reading incomplete files. So Does everybody here know how journaling works? It's a corruption of files in a way. Yes, it is a corruption because a file could be partially. I could be. Think about how we do like a VI, right? Like let's just say I VI temp, Scott file, right? I just make a file like this. Well, check this out. What if I hit I right here, go to insert mode, and I say this is my first line, right? And then I do escape : W, that writes out to my file, right? So now that's what's set in the file. Then I say this is my I say this is my third line, right? And then I hit escape : W. I haven't left the file. I'm still writing into the file, but I've saved the file. So the file is saved. And then I mess up and I say, well, no, actually this is my third line. And then I go back and I fix this one. And the point is I'm doing this in real time, right? And maybe while I was doing that, I stopped to like eat some lunch or something, and I had saved it here. Just I don't know, just out of an old habit, I save a file. This file is no longer usable for what. Let's say it was a real config. I don't know, I was given real. The point is, this is now in a condition where it's no good for anybody. This is a worthless file, right? It's not giving all the what we might typically call directives to the configuration. So services are sometimes robust, and they will sometimes just ignore stuff like this. Like your SSHD config will tend to just ignore lines that don't make any sense to it, and that's cool. That's fine. It's still not a fully configured service like we want, because what the hell's that line doing there? Does that make sense? But the point is, you don't want it reading in real time, because what if it read when I was on one of like my interim fixes before I got all the way done? Maybe I took out some kind of security, and for some amount of time I'm in a security posture that I shouldn't be. And there's just literally all these different things why you would not want to do that. It's the same exact way that journaling works in a file system. You never work on the actual config file or the system file. You're actually working on a journaled version of it, and then when you're ready, you flip the bit to point to the new inode, right? Anyways, that's neither here nor there. It's just that's how that kind of works. So now, I'm going to hit escape : Q, rm-rf temp Scott file. We don't really need it. And then we'll exit out of here and go back to the main node. So we configured all of that basic system over there, right? We set it up, we installed it, we made sure it was running, we made sure it's configured. But now we're going to set up the client on the main node. So now the node over here, the control plane, he's becoming the client to that NFS server. I don't know if export D exists or not. Nope. There's no D in there. But if there was an Etsy export D, you would still want to modify those files and then also still reload, because again, it's not going to. Yeah, it would be like if I was just sitting here, I try not to do this, but like have a bunch of incomplete thoughts. Everybody would be like, "What the hell is this guy doing? What's he talking about?" It's the same kind of thing in the system. The system, if it just keeps reading its config file, it may be in a bad state. So, all right. You don't want so many incomplete thoughts if you can avoid it. All right, so we're going to install the NFS common here. We don't need the NFS server this time. Also, it might be useful to note, whenever you do something like this, you're going to have a log over here in, should be your app log. And it should show us, where's that? Yeah. History log. Down here at the very bottom of this, we should see where we just did that install. And we told it to just install. What? Oh, what am I doing back over here? Could have sworn I got off of there. I don't know what's going on there. I thought I left that server. All right, we're back over here. I don't know what the heck's going on. Oh, and we'll do more on var log when it comes back. Man, that's taking a long time. history. At the bottom of this, we should just see, yeah, the install for NFS Common. And we only told it to install this one thing. So what are all these other things going on here, right? We're looking at a package manager, and package managers automatically resolve dependencies. So if I only told it to install this one thing, what are all these other things that are going on in here? I crashed my bike. Hey, how's it going? Hopefully this stuff's useful to you guys. Oh, if I'm missing anything over here. No install recommends. You could do that. You could do that. But what if we needed those? So what if we actually needed some of these things, right? We only told it to install this right here, the NFS Common. But we got these other tools that may be needed. Yeah, and there's also typically recommended, and then there's also typically the ones that are actually required. So you can maybe streamline this down a little bit if you want to. But for us, for here, we'll say, okay, it took 9 seconds, it says, to install all of this. All right, good. And then for us, we're going to now mount this if we can. So we'll go ahead and say mount from node 01, and then the share that's out there, /MNT on the system, right? We can just mount that. Now, if we do a df-h, we should see that right at the bottom. And the nice thing about the mount command, this is one of my favorite things about it, is the things that are mounted in there show up in the order that they were mounted. And you say, well, why is that? Well, because they're added to the etc tab. So you might say, well, why is that important to know, Scott? Well, because if you told me that mount right here, this MNT, was mounted as the system came up, right? So it's like a system mount that was in etcfs tab at the beginning of the server, and it's been up the whole time. And then I say, well, hold on a second. None of this stuff here got mounted until Kubernetes got turned on. This is all Kubernetes stuff here, right? So I say, wait a minute. No, somebody remounted this later, right? And I just can kind of know that. I can just kind of know that this is the more recent thing. So you might say, well, Scott, that seems like something that I'd never need to know. Well, maybe you're having some kind of weird intermittent problem inside of NFS on one of your nodes, but your other nodes are still up, right? Like your other nodes are working fine. And you can go and compare differences between them. And one of the things you might check is, well, my other nodes aren't remounting it because it's not at the bottom of the file. Or you may know, oh, somebody's been in here and already been working on the server because they've remounted it and it's down at the bottom. So it's just one of those things. It's like one more thing to know about the behavior of your system. DNF dep list. Oh, tomorrow, that's probably over on the. We're on Ubuntu here, so I don't have DNF, but that probably is pretty useful, right? Dependency list. All right. We also got find mount, and find mount will help show you what's happening. Look at all this overlay stuff and SHM stuff, and then we see some other stuff going on, but. We should see, here's our mount right here and where he's coming from. And he's NFS version 4, which is important to know. But then, so where's the system configured? So in this case, right, since we're doing NFS, we have two places where we care about the system being configured. We've got the server side and the mount side, the client side of this, right? So again, we were just looking at NFS. We can come back over here. We could see that it's mounted. We can write a file in there, and then we can look at that file, and we can see that even though we're the root owner of this system, we are not the root owner over there. So, yeah, I crashed my bike. I appreciate that. Said I'm the best sysadmin stream on Twitch. Nice. Yeah, I try to show you guys stuff that hopefully gets you in the industry, right? That's the goal of all this, is show you guys that you can do this. I think a lot of people just sit around and do Linux on their own and don't realize that, or maybe they do realize it, but they don't know how to get into it. Like there's really good work out there that's worth a lot of money, guys. Like you can go do this stuff and make what as we used to say when I was younger, bank. All right, anyways, I'm just kidding. So let's make that persistent, right? So there's a thing about this where what we just did here, where we just mounted it. Hopefully you guys understand this would not persist through a reboot. There's no substance to this right here. Yeah, it's there. Yeah, it's mounted on the system right now, but there's nothing that's going to make it come back up on reboot, right? So there's always there's different parts of engineering. There's the part where I do a proof of concept, or what we call an MVP, a minimum viable product. Those two concepts are very, very important. It's the I got it to work one time, right? That's very important as a sysadmin, and then as you get into your engineering roles where you're building out a new service and you're connecting it for the first time to like LDAP, or you're making these two servers talk for the first time. Never got them to talk before. Now they're sharing NFS, and I'm like, yes, nice, that's good. But that is that is not productionalized yet. That is not what we call ready for prime time, right? That is just set up for this one node this one time. If I reboot this node and it comes back up, I might as well never have put NFS on it, because the other server will still be NFS sharing, but this server will not be connecting to it by default. Does that make sense? When I think of like productionalizing a server, when I talk about like getting a server ready for prime time, let's say, what that means is I'm betting my weekend. I'm betting not being called out on that server working. And you say, well, what does that mean? Power outage, rack goes down. Maybe that one node goes down because somebody trips over the power cord. I don't know. But when that server comes back up on a Saturday night and it doesn't have these things, they're going to call me. And so I'm betting my weekend. I kind of came up with this because, if even later on in my career, and I've been doing this for a while, if I'm not doing the right stuff and not documenting it right and not showing it to my junior engineers, guess who gets called out even if I'm not on call? So you guys might think, oh, I moved up and I'm past on call. No. Nope, you're just the one who gets called when you didn't document it or show your junior engineers how to do it. So actually, I think there's more of a risk of getting called out later on in your career, but it's only, the call outs only are really big things, right? Because you didn't document your shit well. So, all right, anyways, let's go look at this. So let's unmount it. Let's get rid of it. So if we do a df-h on /mount, you're just going to see that it's back mounted off of the normal disk. It's no longer, if I do an ls-l in mount, there's nothing in there. It's disappeared. It's back over on the other system. If we SSH to node 01 and cd to share, there's that file that we made, but it's not on our system. Does that kind of make sense? Fletcher CC, how well is your grasp on quantum mathematics and physics? I mean, I'm probably about as okay as it as any engineer, but I mean, that's not what I do daily. Like, I'd have to go, like, blow off some old textbooks to figure out my physics stuff, maybe go to Khan Academy a little bit, but no, I don't do that stuff daily or anything. I mean, I probably have no more control over that than, any other engineer. That's, Anyway, so let's go look here. I'm going to hit Shift G to go to the bottom in case it's a really long line of files, and then I'm going to hit O to go to a new line. And then I'm just going to add this line right here. So I'm going to click on it, Control Shift V to paste it. And here's the structure of this command. Node 01 share, so where are we mounting from? Where are we mounting to on this machine? It's almost like a, sending an email, or when we used to write letters, where it's from, where it's going to, right? So it's from that location, mounted to here, the NFS file system, the type of file system we want to connect. And then if we have any defaults, or if I only want to mount it read-only, I could put an RO there. And then we have these two, which are always going to be 00 on NFS, always. And this one right here is, when do you do an FSCK against the file system? You're never going to FSCK over NFS, so don't worry about that. And then, are you ever going to back it up? And that's also no. Also, let me show you guys something. Typically in modern file systems, like if you're on like a Red Hat or something, whoops, you're going to see almost always something that looks more like this. And it'll be just a little more cleaned up. And I'm not telling you have to make your files like this. I'm just going to tell you that if you do this, right, you will probably it's easier to look at the file. Like that's probably easier for all of you to look at than what we were just looking at, right? So, something to think about there, right? That kind of stuff. Hey, Colchis, how's it going? We're just hanging out, not working too hard, but we are doing labs today. And on the left, we're doing the lab, and on the right, we're just taking our notes for things that we kind of need to know, right? So, all right. So now we've got that escape : WQ. We can cat out etcfs tab if we want to see it. And it says, where's it configured? So the client side is going to be mostly in etcfs tab, and it's going to be define the mount point. You can also use Etsy systemd files for mounting as well, and there's some stuff that you can do. Fletcher supersymmetry, which is a documented theory of paired particles that explains what Einstein called spooky movement at a distance, unseen connections at the quantum level between particles. Okay, good. I don't know if that's like just the definition or what's going on there. So, okay, let's do on this system. If we do a df-h, we don't see, it's probably easier to search for df-h and then grep-i for share. Just mount in this case. We don't see it mounted, right? And this is like an old sysadmin trick. I mentioned it right here. This is an old sysadmin trick. One of the things that you guys are going to learn when you go to do this stuff and when you're doing this stuff professionally is the most, I don't want to say the most, I almost want to use the term sinister, but maybe that's not the correct way to say it. Maybe the most critical time for a system is reboot. When a system reboots, it comes up like what I consider as an engineer clean. I want my system to boot clean every time, right? Well, mounting file systems is one of the things that will just, for lack of a better term, hork your system up. WHORK, right? Just hork your system. It's not going to work. And it's funny that this thing doesn't know what I'm saying. All right. So we want to test that the thing that we changed in etcfs tab is compatible with the restart of the system. Does that kind of make sense? And I'll tell you guys right now, some of the guys in the server will tell you about having to restart servers inside of like their RHCSA tests and RHCE tests. And they'll tell you that on the reboot, they've broken their servers and it's caused them to not pass because the server wouldn't come back up. Well, in the one example that I know of, the guy that's talked about it, he will tell you that it's as simple as this. You just do a mount-a right here. And this is a little trick. This is an old trick right here. I'm spending more time talking about it than just doing it. If you do a mount-a, it's going to go reread everything in the etcfs tab. And now if I do my grep for mount, it did mount. So that is a clean mount, as close to rebooting the system as I could without actually rebooting the system. I know that change that I made is acceptable, right? It's going to come up properly. So this is kind of like one of those things that I want you guys to think about, right? This is, again, it's an old sysadmin trick, and I'm showing it to you guys so you don't have to go learn it out in the wild. The absolute, like, I have this saying that often comes up. It's not on my little ticker anymore down there, but experience is the hardest teacher. It gives the test first and the lesson after. People think, oh, learning by experience is the best way. It's the absolute worst way. Going and learning by yourself on something and getting all this experience through like hard knocks is terrible. Learn it from somebody who's done it, right? That's how apprenticeships work. That's how college works. That's how literally every type of schooling I can think of works. People try to pass on and get you to bypass mistakes so your road is a little smoother than the one that they went down, right? So anyways, mount-a, really good trick. We can see that it's there. We can touch a file to make sure that it worked. Yep, made it. If we do an ls-l on mount by itself, we see the two files that we've made now, and they're both there. And then now we check this, and it's good. All right. So now we've got two other questions here that I think are kind of pertinent to this. Where are the logs or errors? Like if you try to mount this and it doesn't work, where are the errors to that going to go, right? And then on the other side, on the actual NFS server, where are the errors going to go? If something's not allowed to connect or if something's not there, where are the logs errors going to go? So let's cd to var log. And do we have in here? Let's go see. I haven't actually looked at NFS for logs. It's probably just going to go right to syslog. So let's just grep -I NFS from syslog, and let's see if there's anything over there. And it says that NFS was starting. We see that it was starting. If there was something that wasn't working, we would probably see it here, right? Finish server and service. So we see that. Let's go check. Let's just check NFS from all of them. And we see all the syslog stuff. Let's see if there's any other stuff going on. Got all the syslog. I was wondering if there would be any kind of security stuff. Looks like there's some can't open stuff for reading. That's fine. Kernel log. It shows that there was some NFSD stuff going on, probably in the background. I don't see. We see the install. So this is all install stuff. So we see that. We see that. I'm curious if we could just leave this open too. We can have multiple tabs open on this system if I want. And I can just be back on my control plane real quick. And I can try to just mount things. So mount from node 01, something that's not being shared out, right? So this is just some made up directory. We'll make up temp. Temp is not being shared out. We know only etc share is. And we'll try to mount that to our MNT. Hold on. Make dir MNT temp maybe. And then we try to mount. We're just going to do some BS mount. Node 01 temp to our mount temp, right? Just for fun. And it says access denied. But let's go see if that. So let's grep. Let's just grep temp out of everywhere. And let's see, was there actually a event that happened over on this side that shows that somebody was trying to, yeah, here it is. Here it is in syslog. Refused mount request from that guy for temp because it wasn't exported. I crashed my bike. Will I go over Samba someday? Yeah, I could do a little bit with Samba if you guys want. I run Samba in my home lab. People often notice that I'm running a Windows system, and I use Windows to connect into all my Linux systems, and I use Samba in my home lab. The problem I have with Samba is this, as far as like these labs, is there would be no effective way to show you guys how to connect to it. But like Samba configs themselves, like they're pretty straightforward, right? Like, let me show you guys my favorite thing about Samba. I was showing this to the dudes yesterday on because we do our Linux meetup on Saturday in the Discord. My favorite command probably in all of Linux is this one right here, test parm. Test parm, it's like you're testing Parmesan. I don't know who came up with test parm, but this is how you can test what's going on inside of your Samba system. So if you've got a properly configured Samba on a node, test parm is the way that you can see what's going on. And in my case, in my home lab, I've got my ISOs, my ROMs, and my camera for Ranger Cam, and then also my data here. And they're shared out to anybody as long as you have a valid user for Samba group. So then on my local machine, I can connect in and I can go to data here, and then I can go over to like my, where's the one that we were doing, my StreamWrite stuff. And this is all the stuff that was writing out when we were doing the llama and you could do the !ask commands, and it was talking through the system and going to our LLM. Those things are all done through Samba in our system. And Samba's pretty straightforward to set up. smb.conf, right? And you can just go in here and you can configure things or turn things off, and then you can set your configs. These are basic directive type files. So for me, a multi-user setup isn't hard because my valid users are validated by being in a group. And then as long as the group member can come in, we could definitely go over that sometime if you guys want. I need to put together some of my kind of thoughts on it, but they would be similar to this. So let's see. Where are my logs errors? On the server side, right? We can see a failed mount occurs, and that was in var log syslog, right? We saw that failed temp var log syslog. So that ended up just being a normal system message. Guys, this was not a normal, this was not even, like, this shows right here that this was a failed connection, a refuse to mount, but it's in syslog, it's not an auth log. And does anybody, I mean, from a, like, think about this from like a security standpoint, like a security incident standpoint. Is that being thought of by the system here as just a system like level error, like somebody caused some problem, or is it coming in as a security error? And then I want you to think about the security error, the security incident. Is that a security incident? Is somebody trying to mount something in my system that they don't have authorization to do a security incident? And yes or no? And if you know why, if you know it is, why? Why is it? And what would define that, right? Because I always tell you guys this, like, security incidents are pretty serious in an organization, right? And you are probably going to be, as the Linux engineer and as the Linux admin, the only person that understands the Linux side of things. You're probably going to get called in on that kind of stuff a lot in your career. So, you know, I want you to think about when, I mean, obviously your security team's going to define the incident in that case, but I want you to think about, would you take this and would you share this up to your security team as a potential incident, security incident? And then I want you to think why or why not, right? Like, and by the way I define security, well, okay, so the way I define, the way ISC squared, the way anybody doing security defines a security incident is, does it try to compromise one of the three factors of security? Now, you guys have all heard the confidentiality, integrity, availability model, right? The CIA. That's right. What I want you to think about is somebody that's doing this that's not supposed to trying to violate one of those three things, right? And then the answer probably is yes. They are trying to violate at least confidentiality and see things, possibly integrity. And I mean, I guess if they did enough of those, they might be even affecting availability. So this is 100% a security incident right here. Somebody trying to connect to my stuff that shouldn't. Yeah, we got to go look into it. Could have been just an accident. Could have just been a fat finger. I might have typed something. Yeah, violated. It's an attempted violation for sure, and that's what an incident is, right? All right, so when a failed mount occurs there, boom, and we called that a security incident. How about on the client side? You know, you try to mount something that you shouldn't have mounted, and you'll get, you know, on the command line, failed mount. But what if I did that? Does that also go somewhere? So if I cd to var log and I do a grep for temp out of everywhere, do I see down here somewhere that I tried to mount that and had a failure? Now, there was a bunch of other noise in here, so we might rerun that. Hold on. Let's fail our mount again, and then let's check. And do we see the error in here? Doesn't look like we're going to. So that's probably good, right? So we're not going to see the mounted error here. However, excuse me, if we were to run a dmessage and look for mount, in dmessage, we do see things being mounted here. So we likely would see a failed mount error in here if we were to try to reboot this machine and we had a failed mount point or a security related mount point out of there. What am I doing here? Grep-si temp. Yeah. So we would see things trying to mount in our dmessage. If you guys aren't super familiar, dmessage is just the what they call the ring zero or the kernel buffer, and it's everything that's happened in the kernel since the start of this system coming up. All the kernel messages that are coming out are written in kernel time there, so we can, I love using it for seeing how a system booted, right? Seeing where errors occurred or where things that I did or didn't expect to have happen worked correctly. All right. Is there a monitoring solution to verify? I mean, maybe we have something in this lab. Obviously we don't. But we could write something that would check that. We could node exporter could be used, and that'll go over to our Prometheus. Right, we'll do that in the lab here coming up a little bit. -T on dmessage. Gives the exact time. I like that. Yeah, I like that. Yeah, and then it would let us know if something had happened more recently. I like that. I'll have to keep that in my back pocket. I don't think I've ever used the -T like that. I've always just looked at. So a lot of times when I'm looking at dmessage, I do like that. But a lot of times for me, I'm looking at it from like when the kernel started. So the time is less important to me, but I do think that that's useful for maybe more recent things that have happened. A lot of times I'm looking down here for like, oh, we didn't get this PCI stuff to start, and then that caused an issue with something else coming out. I don't know. There's different things that could happen or whatever. So, all right. So that was our NFS lab. We did that. I think we got a lot of that stuff. We asked ourselves questions as we went. Is it installed? Is the tool installed? How would I know that as an admin? I come to a server. They expect NFS to be on it. NFS isn't on it. Can I fix that? Right? Do I understand that it is or isn't there? And maybe that needs to go back into the pipeline for how we deploy servers if it's not there. But the point is, as an admin and in an admin role, I could find that out. Is it running? Yep, I can see it running. I can see if it's sharing things. Is the tool working the way that I expect? Where is it configured? Can I go look at the configuration? Could I look at that configuration file to see if it had been changed recently? Do I know how to do a stat and that kind of stuff? On the client side, do I know how to go see that the mount point actually is there? Some of you guys might, I've seen all kinds of weird stuff in my career, but you may go to a server and go to the etcfs tab and find the mount point that's there, and they're like, it's missing, and it's just commented out, and you're like, why is this commented out, right? And then you maybe go look through your incident logs or change logs or whatever, and you find out that somebody uncommented it during some troubleshooting last week and just never put it back. Probably just never put it back. Never, because maybe it was a dev box and it was a Friday and the team, he got whatever they needed to working, but he never unrolled all of his troubleshooting. He just shut down and went home for the night on a Friday. And now you're on Monday and the team's calling because they've got this other thing that nobody had bothered to check. It might not surprise you, or it might surprise you if you haven't been in the industry yet. But when you're in the industry for a while, I don't think anything will surprise you. But sometimes when you guys are done with stuff and it's like late in the day, sometimes people just get off the call. It's not like they check down 1,000 things that they know about their server that could be wrong. Should they? Probably, but like your dev teams aren't going to do that, right? They're just going to be done for the night. Their problem got solved, but if that kind of makes sense, it's almost like people just not cleaning up their workspace at the end of a day. So, all right, that's something to think about. All right, so let's go to Apache. Apache's our next one. We're going through labs today, right? We always do labs on Sundays. Here's the Apache lab if you want to do it with me. The labs on Killer Coda are free. They don't cost you anything. You just log in there and they just give you a web browser. It's awesome. Well, you have a web browser, but they just give you a terminal. So let's go ahead and start. And it says your team has determined they need a website to test deployments rapidly. Your team or some dev team that is working with you, they need to have a web server up. They need Apache up. So you're going to deploy Apache 2 web server on Node 01. So that's going to be our web server. Then we're going to capture the version and install Apache 2 for our records. We're going to need that to be able to change our security baseline for that server, because now we have Apache on it and we have maybe open web ports now and things that weren't part of the original security baseline that we had agreed with our security and risk management team, or our GRC team, right, which is governance, risk, and compliance. And you might say, really, you have like an agreement with them? Oh, absolutely, 100%. Because we are just focused on keeping servers built and running and up. They are focused on making sure that everything in the company is within a risk profile, right? And how much you want to work with security on that kind of stuff is up to you. But I will tell you, as an engineer and as an admin, you will run into this a lot. You can't just go changing things willy-nilly on a server. So you want to capture things and understand what versions you have. Then we'll verify that node 1 is listening on that port, and we'll verify that there's some kind of web page up. All right, so those are our original steps here. So jump over to node 01, and we will check to see if Apache is running. So, or is it installed? And we can do dpkg-l grep-i for, in this case, Apache 2, but in a generic sense, it would just be the package, right? And then we can also do a systemctl grep for Apache 2 and see if it's installed on the system. There's no mention of Apache anywhere on the system. If I also cared, I could probably like ls-ld for etc Apache 2. Maybe I knew that that was a directory that would exist for configs. Maybe I know that there's like a var log httpd that comes up. Maybe there's all these things that I could go check. But suffice it to say, if I find that the package is not there, I'm probably not going to go any further. There's no reason to sit here and just beat a dead horse. It's dead. Like it can't be. If anybody here has ever seen Super Troopers, he's pulled over. He can't pull over any farther. He's already pulled over. Cops are yelling at the kids that are high to pull their car over, but he's already pulled over, and he's like, he can't pull over anymore. Well, it can't be any more not installed than it is right now. So, all right. Is it running? Well, obviously not in this case, but how would we see that it's running? Let's go ahead and install it. Right? Let's go ahead and install it. And there's a couple of things that I want you guys to check when you install something, right? Is right here, you'll see it doing it. You'll see it creating the symlinks for it to be set up as an enabled service. But this is very important for you guys as for sure in the engineering side, but also on the admin side. Somebody may say, well, the server just rebooted, but my Apache is off. And you go there and you see that Apache's there, and then you do a systemctl status Apache 2 in this case, and you see that right here it's enabled, and then you see over here that the vendor preset was enabled. That's good to know. That means that when it gets installed it should be enabled, but this is what it is right now, which is enabled, meaning if the server came up and their service of Apache did not when it was set like this, something broke. Now I got to go check the logs. Why did this thing not happen? It's kind of like you're forensically going back through and you're deducing, well, was it supposed to be up? Yes, it is supposed to be up. When this server boots, this thing is enabled, so it should come up. If it did not, if it tripped over its own shoelaces or if something else stopped it, I need to go figure out what that was now. Does that kind of make sense? So you got to test, like I tell you guys always as engineers and admins, you're constantly asking yourselves questions and then you're figuring things out. And the way what we're figuring out here is Apache was supposed to be on when this node came up. If it is not, now I got to go figure out why, right? So is it running? That's systemctl status Apache 2. We could do ps-ef grep-i for Apache 2. We can do ss-ntulp and then just look there, right? So let's see some of these other things that are going to come up here. We should be able to do, yeah, ps-ef grep-i for Apache 2. I see it running. I should be able to do an ss-ntulp, and I could grep for all the ports that I know it should be, which are 80, 80, 80, 443, 8443, 8443, right? Those are like the default ports that we're going to kind of run into. And yeah, I see it running on port 80 on my system, right? So, I mean, if you wanted to do that, I ignores case E is an extended grep, and then 80 or 8080 or 443 or 8443 in that case, right? That's just another way. And then if you knew the port, this would be fun too. You could technically do this too, lsof-i port 80. So if you knew it was port 80, you could look for who's holding open that 80 port on the system. So is it running? That's a whole bunch of ways to do it right there. Now, if you knew there were other ports, you could check those out as well. Oh, also, I'm missing people's follows. So Fletcher and DOS and BlueCon. Hopefully this stuff's useful to you guys. So, monitoring, is it installed? Is it running? We can check those things. We can see those things, and we can kind of see what's going on. Now, if we rerun our D package, we would see that it's there, and we would see the version of it, right? 2.4.41 is the major, the minor, and the patch version of a thing. And if you don't know that, this is one of these things where I tell you guys it's important to know your semantic versioning. Semver.org. This shows you how semantic versioning works. Very, very useful as a systems engineer, very useful as if you're a software guy, you're going to use that all the time. But for us over on like the platform engineering side, I still need to know those things because that's how security is going to report incidents to me. Security knows vulnerabilities based on package versions. That's how CVSS scores get assigned. They show which packages they've been proven against like Apache to be vulnerable on. That's how they're always reported. So if I was on Apache version 2.4.41 and a new like CVE, a new common vulnerability, what is it, and a set, whatever CVEs stand for, and it gets a CVSS score of 10, but it only affects version 2.4.40 and below. Well, we would not have to change anything on our environment. That would be what we call a non-issue. But if I went and audited all my systems and found that like 10 of my Apache servers in prod were actually on an older version, now I have an immediate thing that we need to start looking into fixing. We need to, there's a whole bunch of risk stuff that probably is going to quantify how you do that work. But suffice it to say, I now know there's a problem. I need to typically report the problem up, right? I tell you guys all the time, like I know a lot of engineers who like their hair's falling out and they're stressing and this and this and this. I don't stress about things like this. If I see a problem in the environment and I report it up, I sleep fine that night. It's kind of like if any of you guys ever saw Good Will Hunting, where Robin Williams gets really stressed by something Matt Damon tells him, and then he goes, you know what, I thought about something about you, and then I slept really good until now. I haven't even thought about you since. And basically he tells him, he talks, because they're talking shit to each other, and he tells him, you know what, you could recite me all this stuff about love and sonnets, and you can tell me all this stuff, but you've never stood in the Sistine Chapel and looked up. Basically he calls him like a punk kid. He just does it a little nicer. It's actually pretty good little scene. But it's the same thing here, where it's like, if I report stuff up, I never have to think about the problem again. I'm just the engineer. The management can go fret and be frustrated about stuff. My job is just to tell the truth about what the system is. So unless you're building busted systems, and then that's on you. But anyways, all right. So where's this system configured? Where do we get the configurations for all of our Apache stuff? By the way, let's make sure that the firewall's off. That's for fun. And we're gonna configure this on this node. So let's go ahead and not worry about that configuration yet. Let's exit out, and then let's do a curl against node 01 and see that we do have a web page. Here's a working web page, and it actually says in here that it's Apache. So is it running? And we see the web page. So where else from? So a remote node. We can do remote node. We can do curl. Node name. Right, and then the port number if I know it, or if it's the default port, I don't need that. But let's say the port number. And also there's some other ways we can do this, right? We can also do this. If we have Netcat, we can do NC to node 01 on port 80. And I should be able to add a -VZ in here. And it'll say, yes, I connected to that port. So this one would also tell us that it was there, right? That's a pretty good one. You also have Telnet. Telnet's useful. But you might say, well, why would I want to know that a remote node can't get there, but maybe I can get there from my own node? So maybe I go over to node go back to node 01 real quick. Oh, here it is. And then I do my curl 127.0.0.1, and I get that page again, right? But maybe someone else can't. Why might I want to know that, right? Well, it's possible you've got your firewall on here. We don't. And it's possible that something exists between the network here and the network there that blocks it. Like in my home lab here, if I just showed you guys, if I just went to like one of my internal Rocky boxes, right? And I went to and then SH2 Rocky 1, let's say. We don't care about any of that stuff. And what? Hold on. That's weird. So we SSH to Rocky 1, right? And I tell you, okay, you guys all SSH to Rocky 1, and then from your homes, you guys type in SSH Rocky 1. It might surprise some of you to know that Rocky 1 is not a globally unique name, and it does not have access for people to get into it from outside. And if I even had a web server running on here, you wouldn't be able to get to it, because in between here and there's this vast gulf of networking and other things that you can't just go outside and yell Scott and have me hear you. It's not going to work like that, right? There's this big gulf of things in between. Well, I mean, there's DNS issues, there's connectivity issues, there's the fact that this is only connected on a internal IP address that's non-routable on the internet. So even if I showed you that it's 192.168.200.51, you can't get to that. That's not routable over the internet, right? You would have to know my external. There's all kinds of things that would have to happen, right? Well, the reason I bring that up is here, it's the same kind of concept. I don't know all the things. Let's say I'm a new Linux person to the company and I try to curl from my jump box to some set of nodes and it doesn't work. I cannot conclude that those nodes are not doing what they're supposed to be doing. I can only conclude that I can't get there from my system. I may have to go somewhere closer and test because maybe they're in a PCI environment and port 80 is not open outside of that. That's very common. We don't allow a lot of communication into our PCI environments. We lock them down inside of companies. You could also be dealing with, nowadays, you could be dealing with initiatives to move over to zero trust, where only devices that should be able to talk to things can. And now your old version of testing where you just curl and see if a node's open or not, it's not valid anymore, right? Does that kind of make sense? Hopefully it does. So is it running? Yes. All right, I beat that dead horse there. Let's go over here. Now, where is it configured? Let's go see how this system's configured, because now we're going to get to this next part where you've set up a web server and we know it's sharing port 80, but your team has a requirement that they want to test against 3 different environments. They want a dev environment, a test, and a QA environment. So they want to set up these other ports listening on this system. So now we've got to go figure that out. So SSH to node 01, and let's go look at the solution here, right? So SSH back to node 01, and it says we're going to make the directories in var www. So where is it configured? There's a thing called the document root, and that is in var www HTML by default, but we can make more of them. In fact, we did just make more of them. ls-l and var www, and we see these other ones that we just made. Now, just by making those, did we do anything? Did we make them accessible by the web server? No. We just made a couple of files, or 3 files. That's all we did right here. And this is also me kind of introducing you guys a little bit to, you guys are being kind of just introduced here to the concept of wildcard expansion. So if you've never heard that term, this is the thing you need to know as a systems administrator. It'll make your life a little easier and it'll make things happen faster, where you can set a command and then you can allow bash to expand on what that command is doing, right? Easiest way that most people learn this is this. You cd to temp, and you need to make 100 files. Somebody says make 100 files, and you go, oh gosh, okay. Touch file 1, touch file 2, and then you're like, oh gosh, this is so hard, right? But then you find out that there's a thing called a wildcard expansion, and you can just do this. And it'll make all the rest of them for you. Just made all the rest of the files for us. We didn't have to know how to do it. We just knew that it would do that command over and over again for the wildcard expansion, right? That's what that term means. But anyway, so where's it configured? I don't know. I'm getting far afield. But now we see this directory that wasn't there earlier. We saw earlier that this wasn't there. But let's go to Apache 2. And there's a bunch of stuff that's shown up in Apache 2 now. And in one of our files, we have these things for ports. So where is it configured? We have that. We can etc Apache 2 has a bunch of files, right? And then in here there's ports.conf. And let's go look at what ports.conf. Let's go look at what's going on inside of that ports.conf file. So it's vi ports.conf. And it says, okay, if you have to change the ports or add more ports here, you can do it. And then we can have some modules that happen. And here I've got this listen 80. All right. Name glob. Yeah, name globbing is a good way, I guess, maybe to think of it. So I'm going to hit YYPPP. And then I might just come here and change this. I'm going to go ahead and and go 8080, 8081, and 8082. Now I'm going to hit escape:WQ, and when I change that ports.conf, do you guys think that Apache is now listening on that, or do you think something else needs to happen before Apache is going to listen on that? And how would I validate that? How would I validate that that did or didn't actually change the way that Apache was working right now? And by the way, for some of you, you might be like, Scott, this is really stupid simple. Like, are you really showing that? And I'm going to say, yeah, because some people have never run an Apache server, right? Like, we forget, like, because we've been running, like, Apache servers in our environments for 20 years, right? Some of you guys have been doing this a long time. Yeah, but for people that have never seen this before, this is all brand new, right, for them. So I did that, and I've got this tool, ss-ntulp, and I can see what my system's listening on. It's only listening on port 80 right here that I can see for Apache. I can do ss-ntulp grep-i for Apache and see that it's still only listening on port 80. So I say, okay, well, I want to get it to listen to that, so I got to restart the service. I know that. But is there some more config stuff that I need to do? Well, let's go look. Again, we're still in Apache 2. And let's go to our sites.enabled. And in here, there's this default.conf that shows us how we can set up a virtual host. This is a real long file that I'm going to make this a little smaller so you guys can maybe read that better. And it's a really long file that shows a virtual host, has to have a server admin and a document root, and then you can have an error log and a custom log, and then it closes out. So this is a virtual host defined to listen, in this case, to anything on port 80. And all these are comments, so these things don't really matter. The only thing that matters in here is the start and the finish, and then these little values in here of where the document root is. Right, here's our document root, which was by default this. So let's go down here and let's add this file in here. So I'm just going to hit the VI in here, and it'll be testing team conf. And I'm going to hit I, and I'm just going to copy all this right here. Copy all this over here, and then Control C, and then I'm going to come over here and right click and paste it. And look at this. This if you've never seen this before, we do need to do, well, we don't need the daemon reload for this, but we do need to reload the Apache 2. Hamed, yes, that is true. But check this out. I want to finish setting up my configs. So now I've got a virtual host for the listener port 8080, and he is going to be listening to, remember we did those 3 document roots earlier for HTML dev, test, and QA. So now we've made those folders earlier, and now we're going to tell the system if something comes in for port 8080, I want you to go drop into var www.html_dev as the default the document root, right? So I'm going to save this. And again, we'll go look. Is that listening? No, it's still not, right? Still not listening on that yet. But then we're going to make a web page. So we're doing 3 things before we reset everything. And in each of those directories, so in var www.html dev index, I'm going to make a page that says I'm a dev page. Excuse me. There's my dev page. Then I'm going to go into the test page. I'm going to make the simplest little HTML I can make that says I am a test page. Then I'm going to come down here and I'm going to make the simplest little QA page that says, oh damn it, says that I am a QA page, right? And then when I've done all of those things, I'm going to restart Apache. And now, if I go and I listen, and I go and I look at those pages, now I see the listeners open for all of those. And on each of those pages, I see that they're open. So we're listening to 8080, we're listening to 8081 and 8082. And then if I really want to, I can curl all of them, and I can see that I see the dev page, the test page, and the QA page. So this is all part of the lab, and this is all part of stuff that you guys can go do and see. But where is it configured? So Patch 2 has a bunch of files. There's ports. There is the site. Was it? Yeah, site's enabled. So it's etc Apache 2 site enabled. And then in here you can make any files you want for file config. Any files you want for more listeners for those different sites. And then we also have our, document root. And that is configured in var www.html for each page, let's say, right? And the point of showing you guys all that is you could make a functional web page for your different teams, and then all they would have to do is drop whatever they were testing into each of those. Now, there's some other things that could happen, like if there was more functionality on the page that's needed and more modules and stuff, and you can keep building on it. But this is the very basic to get like a web page up and running on your system. All right, we hit check. It says, look at you learning Linux. You created a web server. You changed the listeners to different ports and the document root locations. All right. So now I might say, where are the logs or errors of these things? So we configured them while we were doing this, but let's go over here real quick, and I'm gonna make this a little bigger so you guys can see it. And I'm gonna say from control plane here, while true, do, and we can do this as their own individual lines, or we can just do it here. Let's say while true, do curl 127.0. curl node 01, and let's go to port 8080, and then port 8080 like this, 8080, and then let's say that we do that, and then we say curl node 01 8080 broken, and then sleep, we'll do sleep 2 done, right? So now this is going to go, and it's going to be doing something in that environment. And let's cd to var log Apache. And in here we've got access log and error log, but then we also made these for each of these different parts. So there's an access log for dev and an error log for dev. So let's tail -f on dev access log, which is one of the systems that we're hitting right here. And there is our access, people trying to get in, and we've got a 200 and a 404 here of them trying to get into the good and also the broken connection. And then I'm going to go look at the error log. Error log. And we're not seeing any dev errors coming in. So this is interesting. The system is not showing as an error because it is giving it a 404, which is the page not found right? It's not finding broken, but it is finding the other one and giving an exit code of 200. So both, even though that's still happening, it's there's no error happening to the web server. The web server is performing properly. The broken link is getting a 404. So this is an interesting behavior to note. It is not broken to ask for something that's not there on the correct port. It's still showing up as, hey, that was a good request. The person tried to do something, and then I just happened to give them a 404 back, right? So that's not technically an error to the web server. Error may be, I don't know, maybe we have a bad header or something. We could try to figure out what would give us an error. But the point is, we can see down in, we made our own errors, our own error logs for each of these. But it's down in var log Apache 2. And then we can say custom error based from var. And that's in the sites enabled, so from the directives. And if you say, Scott, what's a directive? This was the directive. If we come back over here, and we'll come back over here, make those a little bigger so you guys can see it. Here was our virtual directives, etc Apache 2, in our sites.enabled. This is a directive right here. This is what we call a virtual directive in a Apache server. Enzo Bear, how's it going? We're not working too hard. We're just doing labs today, and I'm showing a lab that we've done many times, but I'm showing you guys over here maybe some things that you might want to know about it. Wait a minute, what happened here? What was going on here? I am in the oh man, you guys gotta stop me sometimes. I went down too far. It's gonna be monitoring here. All right, so we were doing Apache there, and we did all that, and we looked at the logs, and then it says, is there a monitoring solution to verify next lab? Right, we'll look at some monitoring solutions to see if things are working kind of the way that we expect them to. Okay. But anyways, look at you learning Linux. You created a web server, changed the listener for different ports on document root. And for some of you, you might think, oh, that's really simple. Yeah, but for somebody who's never done that before, that's probably an exercise in something that they're going to need to go do a few times, right? They're probably going to need to spend some time with this to kind of absorb what we just did there. By the way, I'm going to take all these notes and I'll drop them in our meeting notes on the Discord. So Enzo Bear gave you guys the Discord over on the Twitch side. Let me go take that and put that on the YouTube side. If any of you guys want to join, you're always welcome to hang out down in Discord with us. We got about 3,500 people down there now. We're just under 3,500. And, people have varying levels of activity, but I don't care as long as they're just kind of hanging out, absorbing stuff and working on stuff as they want to, right? I think some people are tech adjacent, like they're not really doing this type of stuff and they want to just kind of follow along with what's going on in the Linux world. Some people are trying to get actively into these type of roles because they like doing this stuff. And I want you guys to be able to hang out with a group of people that are doing the same type of stuff. Yeah, Zorgul, yeah, this is what we do around here. We hang out and we do this stuff. Also, Ryo Satan, aka One, on the Twitch side. Thanks for the follow. Let's do a little bit of monitoring. So we did NFS. We set up NFS and we asked ourselves questions and figured it out. We did some Apache. Now we've got a bunch of monitoring stuff. I really like the monitoring labs because they get you more hands-on. But we're gonna say throughout all of this, are our tools installed? Now this is going to get a little more abstract because there's going to be a lot of tools. What we're building here, these 3 labs, they build this out. For you guys that haven't been here before, this is what they build out in the home lab environment. Let me get rid of this thing. This thing's terrible. Don't save that. We were messing with colors yesterday. It was a whole thing, whole joke thing. But here's our monitoring. We're going to have Grafana as our endpoint, and we're going to send everything into Grafana eventually. But Grafana doesn't store stuff. A lot of people, you can use Grafana for minimal storage, but that's really not what the Grafana tool is designed for. You really want to have some kind of storage layer that's doing the time series database like InfluxDB2 or Prometheus, even Graphite and some of these other tools. They're just designed to store the data so that Grafana can read and present it, right? Ingesting from the servers are how do we collect the data. Some people would call these collectors, and they either push data or get data scraped off of them to hold in our time series database until it can be presented. So these are the things that we're going to build right now in the big scheme of things. All right, so let's go build some of that. We'll start first with Promtail, which is going to be logging. We're going to do some logging in our environment, and we're going to look at how logs kind of look. If you guys have not done this lab with me before, this lab is, I think, one of my... I really like this series of labs because it shows you guys a hands-on tool that's very useful. So I'm going to make this really big. And it says your team has determined they need to offload and monitor logs in your environment. Linux logs need to come off the servers in real time. And you know that Grafana can do that. So you plan on deploying it as a server daemon, right? So we're going to deploy Grafana and ensure that it's running on our server. That's task one. We're going to go to Grafana docs if we want and oh, hold on. Here's the lab if anybody wants to do it with me. So I'll link it on the YouTube side, and I will link it. You know, I haven't pinned one of these in a while. I'll pin it on the Twitch side, and then I'll just pin it for, we'll pin it for 20 minutes. So we'll be in here 20 minutes at least. And very first thing we're going to do is install just some prerequisites. So there's some prerequisites over here. And we're also going to install the GPG key. And the GPG key, what that does is it allows us to go and download from Grafana.com a key that they use when they sign any of their software that they push up to their repository. And what that means then is if we go and we add that key into our trusted, it's in our key ring, and we trust anything that's signed by that to be software that actually came from them, then when we go and install our Grafana Enterprise, it's going to check it against that key. We got that key in what we call an out-of-band fashion, meaning we went and pulled it, not directly connected to this communication here. And now we have a way to validate that this is from them, right? It would be like if somebody in your family said, hey, that person's coming over to Scott's house today. And I said, okay, how would I know them? And they go, well, here's a picture of them. And I got a picture from them, so that's an out-of-band channel. And then when you show up and I compare you to the picture, I go, yeah, looks like you. It's the same kind of concept. They're just doing it in cryptography, right? You don't have to go spend your life crawling around cryptography if that's not something that's interesting to you to understand the simple way that it works, right? If you want to go spend time in cryptography, then do that. And there's nothing wrong with it. Now we've got Grafana running on our system. Let's make sure it's turned on. So we're going to do daemon reload. We turned it on. And then here's the thing. We're going to check, and we're going to see that Grafana's running, but it's not listening yet. The first time we turn Grafana on a system, it takes about 10 seconds to come up. So if we wait about the time I was just talking, now we're listening on port 3000. Over time, you will kind of get used to Grafana always being on port 3000. Prometheus always being on port 9090, right? There's these common ports that are going to kind of be useful to you. So I turned that on. Now I've got this link. Every one of you will have your own link if you're doing the lab. And now we will go and we will look at Grafana right here that we just stood up over the internet, right? Admin, and we're going to give it a password. My password is going to be 1234567 and 1234567. I know it's super secure. And now I'm in an instance of Grafana that never existed before right now, right? It's exposed out to the web. I've connected to it. And I've changed the default username and password, and I can go play around in the UI for a bit if I want to. I don't want to. I want to keep going. And it says that our team has decided that the log aggregator will be a tool called Loki. So Loki sits in your environment and just gathers pretty much anything that's going on. So in my home lab, if I look up my logs right? And security. This is my home lab here. And if I just look at my secure and failed, I can see anybody that's tried to come into my home lab here in the last 6 hours. These are all the failed login attempts to my home lab in the last 6 hours. And then people get themselves banned out forever. Some of you guys kind of know how this works. But it looks kind of messed up because I changed the logging format a while back. But also it's on a smaller window. But let's go ahead and get Loki stood up. So Loki is, we're going to do, this is a little different, the way that we do this install. We're going to make a directory for oploki. And then we're going to cd into that directory, and we're going to download from the Grafana GitHub the version of Loki that we want. So we're going to get 297, and then we're going to also download, we've got a local config that I've set up, and then we're going to go and download their, oh, we don't download any of it anymore. I guess I did all the configs myself. We're going to start it, and then we'll go look at the local config. Here's the config that I made for this. And actually, I think this one's all default with the option, with the difference of we took these out because these don't work anymore, right? Oh, and this one too doesn't work anymore, so we pulled it out. And Loki is just going to sit here and listen on port 3100 for people to send information over to it. Good. Then we're going to look at the service. Service is super simple. It just says start that Loki executable that we downloaded and run that config file that we also just looked at. That's all it is. I do want to show you guys one thing that's kind of annoying. I kind of dislike this. If you look at the very end of their config file, they've got this by default Loki won't do any of these things, and oh yeah, we're doing all this stuff. And then down here they say if you would like to disable reporting, uncomment the following lines. And then set them, it'll be set to false when you uncomment them. But that's kind of like a dishonest thing because, and here's why. Typically in config files, if something's commented out, that's the default. But they right here, when you first download this from them, that is not the default and it is commented out. So that's a very backwards way to do it. What that's saying is you are inherently, if you download this, you are sending up your data to Grafana Labs. Now, in the home lab, don't care, do whatever you want. In the enterprise, I can promise you right now, no enterprise security team is going to be okay with that in what we call a carte blanche way. What's carte blanche? It means just fucking give them whatever they want, right? No, we are not going to give them whatever they want. We are going to uncomment that so reporting is false. Always get in the habit of knowing the tools that you're installing in your system, what their behavior is, because you will be the one answering for it later. And your security team, I guarantee you, your security team does not want that to just be sent up. Good security teams are going to see that, and they're going to be like, why are we sending this data off to this company? And then they're gonna have you change it anyways. So, and you might get a little slap on your wrist from your boss. So you really don't want that, right? Especially if you're kind of starting out in systems engineering. It's like a big face palm to just punch a security hole like that for no reason, right? Know how your tool will work, especially if you're the one that recommended we bring Loki in, and then all of a sudden it's like this thing that's just sending all this data off. Look, they probably anonymize it, they probably do all those things, but how do we know that? We can't just give access to our systems, right? I mean, we don't want another one of these Falcon Strikes, and we don't want another one of these SolarWinds. If you guys are familiar with those were terrible. Those were terrible. Billion systems taken offline by Falcon Strike, and they still exist. I can't believe it. Falcon Strike is CrowdStrike, right? It's Falcon Sensor is the name of their sensor on the Linux side. But anyways, all right. So system enable Loki now. So we'll turn it on, and then we'll look at it, and we'll see that it's running, and we'll see that it's listening on port 3100. Those are the things that we care about. So is a tool installed? This is always typically like dpkg-l, grep name of tool. Is it running? We can do our systemctl status, name of tool. And in this case, we saw that Loki was running, and then we can also check its port number and see that it's there. These are the kind of things that we do, right? So that's running. Now, the very last thing we need to do is get the logs off this server into Loki. If we're here, we've set up Grafana. We've set up this tool Loki in this lab, and now Promtail needs to push logs over to Loki so that we can visualize them in Grafana. We've got to have the data has to have a full channel path to flow from the user agent on the system to the storage to the presentation layer where we're going to look at it, right? So, come over here. You found that in your research, Promtail tool can push over to Loki in real time. Your task will be to deploy and configure Promtail to push logs to the server. So install Promtail. So we'll make a directory for it in opt. That's where we put third-party tools and agents, typically. You can put, like, you put stuff wherever you want in your Linux box. I'm just saying this is where most people put it, and it's probably going to be the most supported by other people. And your team should probably have like a standard for where you put third-party tools. Also, you're probably going to have to get it through security and approved and all that kind of stuff. So let's download and extract the tool we're going to use to push over for Promtail. And then let's go look at our file. Here's our little config file that we made. Now this one, I made this one myself. I modified these two because typically when you download this, if you go download it, you'll see this pointed to varlog messages and varlog secure. And is that fine? Absolutely. Varlog messages and varlog secure are where you send things. Those are the two most common logs for Red Hat systems. But we're on a Debian system. We're on a Ubuntu system, right? So syslog is varlog syslog, and then auth-log is varlog auth-log. So we want to track what's going on the system. We do that. And then how do we start the service? We start the service by execing the executable file we downloaded and that config file we just looked at, and we tell it to go push to Loki, which is on our local machine running on port 3100. So there's all these pieces, right? We do a daemon reload, comes up, and then we should be able to go see that service running. Everything's running on our box. We see it is found, and there's the agent running. So if that's all there, we should now be able to go into Grafana and set up the Loki data source. There's two things we need to do in the Grafana. Set up the Loki data source and then create a dashboard, right? So let's go see if we can do that real quick. We're on the Grafana box that we just did. And to get the data source, they're called connections now. But here's our data source. We can look up Loki. Here it is. And how are we going to connect to Loki? We're going to add a new data source. By the way, this is all kind of described right here in the solution, right? So we're going to go create a new data source, Loki. We're going to use our local host on 3100, right? 127.0.0.1, 3100. We don't have any special authentication or TLS or any of those things, but we could build that in. And then we come down here, and one of my favorite things about this tool is when we go to connect right here, it'll tell me I was able to connect to that data source. I tried to connect, and Loki gave me some kind of response back. That's cool. That's good. So we've got Loki set up. We'll go ahead and it's saved and tested already. Good. We're going to go and we're going to go to our dashboards now. And we're going to make a new dashboard by importing a specific 13639. By the way, that's over here, 13639. I'm going to load that dashboard. And it says, hey, I'm the logs and apps. And I'll go in my folder dashboard if I want. And we'll go connect it to Loki. This is the data source that we just brought in. And we'll hit that. And immediately we have auth and syslog right here. So let's go ahead and make sure that this refreshes every 10 seconds here. And let's go test that this is actually doing a reporting out of what's coming out of auth. So we'll come over here. I like to show you guys, whoops. I like to show you guys like this real quick here. Get that out of the way. Get that out of the way. Excuse me. Let's do this. Let's say clear for user in and we'll say sequence 1 to 100, do user add -m, and then we'll say user $, user sleep 5 done. So this is just going to start making users in our system. And if we sit over here and watch it, I'm going to crunch up a water bottle and look, my hands are not on the keyboard. Watch this right here. Every few seconds, you're going to see more users pop up. And those users are going into varlog auth.log as it's creating users. But now we're watching that happen in Grafana. So on the Grafana side of things, where the data are flowing all the way from the node, right? And it's on the same node, but it doesn't matter. Promtail is pushing up to Loki. Loki is being read by Grafana, and then in real time it's refreshing over here and seeing that somebody's making users on our system. Could this be a security violation? If it's not supposed to be there, absolutely. Might this be something we'd want to know? Absolutely. Could we set up triggers now and have events triggered off of these things happening from Loki? Yes. Yes, we absolutely could. So, this is not the only way to do it. Another way I've seen that's pretty effective is you could write events out into Kafka, and Kafka can be the system bus, and then you use a tool like Elasticsearch, or you could even use Kafka again to pull them back out of the event bus once you have them. And you could use Kafka as an event bus for your entire organization, like a big old log pool, and just pull out events that are like user add. Why and trigger every time. Why was a user created? Why was a user created? Like what's going on in our environment that's causing users to get created when that's not a normal behavior? And maybe you have a service that makes a user every day just to check. That's acceptable. But 5 users in an hour, that's something that maybe we want to track and use and look at. So the reason I show you guys this is I mean, I've told you guys this before, but like there's engineering and there's art, right? Engineering is when I can tell you a discrete set of steps. We just did a discrete set of steps, and we set this up right here. We set Grafana to monitor Loki with Promtail agent pushing over. I can give you the formula for that. We even have one of our guys, Kolkis, for his lab. I don't know if he's still around, but for his lab in our Linux Systems Admin course, he built these things to be deployed via Ansible. It's really awesome. It's something that would be valuable to go do as a consulting service or as an admin in a company. Very valuable, right? In fact, for our Prolog group, I'm trying to get Chris, one of the guys I used to work with, to come talk to you guys about how he and I set this up at the college that he still works at. I was a contractor for them for a year, setting up their team, and then he's one of the guys that kind of ran with the Grafana piece. But I want him to come and talk to you guys about this. Anyways, where I'm going with that is, where was I going with all that? I don't know. I forgot where I was going. Lost my train of thought because I was thinking about taking a break. But wait, let me come back here. This is engineering. When we can draw it up and I can give you a discrete set of steps and then we can boil that down into an Ansible playbook and we can deploy everything, that's engineering. But what you should track and like how you should trigger alerts and stuff, that's up to interpretation. That's what I call art. So the difference between art and engineering is if I can give you a discrete set of steps to do something. Art is where it's like, well, it's a little bit of this and a little bit of that and a little bit of, and it's good, right? It's like a little chef's kiss. If that's art, and there is an art to monitoring systems. This is engineering up to this point, but what you want to do with this and how you want to present this to your security team and your upper management and all these other things, there's an art to that. And that's a thing that I can't quantify. In fact, I'd argue I'm not even good at that stuff. I can show you how to build this stuff all day. What you want to do with it, I just draw a blank on that. I'm like, well, I got all the data. The data are available, right? But what are we doing? What are we doing from there, right? Like all that kind of stuff is up. So anyway, so monitoring, is it there? Where is it configured? Multiple places. But I like to put agents in opt. I always put agents down in opt. That's a big thing for me. Logs errors, we're sending to Loki, right? Like send your logs off the system. So I'm still making users, by the way. It's kind of slow. Ubuntu firewall, UFW allow, UFW status. Knitting. Yeah, those are all commands you could use, absolutely. Yep. Oh, got my lid on here. So we could watch this or we can go and stop it or whatever. But the point is that system is going to continue to write and make those users, and then it's going to continue to come out over here where we can either make it an incident or make it something that we monitor or whatever we want to do with it, right? There's a lot of stuff that we could kind of do from here. All right, so that was our first of those labs. Is there a monitoring solution to verify? Yeah, send it to Grafana. I'm being a little tongue-in-cheek on this one. Like I'm being a little silly on this one. We're not worried as much about these. Also, by the way, if you're in our Discord, which here's Discord. Discord's free. You guys can hang out down there. We have stuff on this. I feel sometimes like when we look at this, like that we've beaten this as like a dead horse. Like I feel like I'm just beating this one because in our Discord, if you go look at this one, we have projects on this. Our original kind of presentation series, I think, has, if you go to the very beginning, maybe it's not presentations, projects. It's the very beginning of projects. If you go up past all this stuff that we did for the Linux Systems course, this one started, the very start of this course, or the very start of this channel, was us doing these logs. So here's all the log labs, and then there's a monitoring deep dive project guide. And then what would happen is you would go through the project with all the labs and look at everything, and then there's a project guide where you can go and you could add these individual pieces as you were grabbing things out. And I have do I have it? Let me see if I have it actually in this lab. Let's go look here. See, we'll stop that CD to answers. I did put it in here. So I'm going to copy. Actually, we'll do it right here in the answers file. It doesn't matter where we do it. Normally, I'll copy Loki .py to root cd root. All right. So now I've got. Yeah. So let's go look at this Loki write.py. And this is a little thing that I had put together where I was showing you guys that we could do. If you're somebody who uses Python or you use some other tool, you're just hitting an API endpoint, guys. This is not rocket science. What I'm showing you right here is not rocket science. It might look a little complex to start, but after you do it a little bit, you're like, that's it? That's not super hard. So watch this real quick. We can go and what are we going to do? We're going to try to run some Python. And it's going to need requests and JSON and data and PyTZ as libraries that we can import, right? And then it's going to go against the host control plane. And we're going to push a message to the API prom push. And we're going to go give it a payload, which is some information we want to dump in there, right? Well, let's go see if this works. Let's just do a Python 3. And then Loki write py. Let's just write that. And it says we got a 204 response. So it says lab logging and then the source and the job right here. So we come back over here and we've got these two things. Let's go ahead and refresh this page real quick. If that all pushed through, now there's an app for a job here, and it's on server control plane detected error. Scott is too awesome. Was that our error that we had right here? Where's our error up here? Yeah, message on server host detected Scott is too awesome, and then that got pushed down into here. And then let's go ahead and just say while true, do that, and then maybe like sleep 3 done. So we'll just let that go forever, and then we'll just sit here and look. My hands are up here. I'm not typing. Not typing anything. Every 10 seconds, though, that thing's going to come back up. Look, I'm not typing. There's the little error messages. And it might be nice to note that they're starting at the oldest on the bottom and the newest one's up top. So you're going to get it in reverse order. You can also switch that if that bugs you. You can make it read in the other order. But now we're writing from our own logging. So one of my buddies, he doesn't stream as much anymore, but Salty Catfish, when he comes on, I know him he and I work together professionally a couple times actually, and I really like the guy. He does really good brown bags on Linux and testing and stuff. So you could make any of your when he does his Python, he does a lot of Python coding. He's a professional guy. He's been like a team lead the whole time I've known him. He's been a software engineering lead for like big teams. Probably like when I say big teams, I mean like 15, 20 people, which is pretty good size if you're not like in a big company. But yeah, he's a lead, and he teaches people how to do stuff, and he's very controlled in his repositories and his branches. He shows you guys how to do all that stuff when he's streaming. But he's also down in our Discord, so he helps out a lot. But he always logs out the files and stuff. And I was saying you could take any of his stuff where he's logging out to a file and say, well, what if I deployed this to like 100 servers in my environment? And as all those servers did whatever they did, they just checked back into this one Loki endpoint. And so I could just deploy my stuff via Ansible or whatever deployer method I wanted. And then I could just sit here with my feet up with this on one monitor and Netflix on the other monitor and just make sure that all my damn nodes are checking in. And if any node doesn't check in, we could validate it real quick. We could just check to make sure I see all my nodes, 0 to 100. All my nodes are up, or 0 to 99 or whatever. And all my nodes are good. And if one doesn't check in after so long, we just go check on it and go fix it, remediate it, and then we're done. I call this stuff like painting with a wide brush, because a lot of times I'm maintaining more servers than I have people for. You know, I have me and a few other junior engineers trying to fix stuff. So we try to paint, you know, if we're going to patch 1,000 servers tonight, we'll try to get 980 of them done. And those other 20 we want to detect quick so we can start remediating them so we can be done earlier on in the night, right? Like we want to, if we're patching all night, you know, then it's good to know where everything's done. So anyway, so look, Scott's too awesome. It says it right there. I mean, I have definitive proof now that Scott's pretty awesome. I wasn't sure if I had put that in there, but that's if you do the lab. That is kind of like a little bonus hidden thing down in the answers portion where you can go look at writing with Loki. You know, writing with Python into Loki. By the way, some of you might say, well, do I need to use Python? Guys, that's an API endpoint. You could probably like use a sausage to... I mean, as long as it can do an HTTP post, you should be able to post into an API. An API is what we call technology agnostic. An API should sit there and listen to any well-formed web request, right? So it doesn't matter what you're pushing. Nitin, I normally use Ansible for patching, yeah. We have I have some topics in our Discord about it and stuff. I actually promised the guys one day I would show you guys my whole how Ansible works to patch things. So I do need to do that one of these days. All right. So anyways, that's that log, or that's that lab set up for you guys there. So hopefully that's good. And then Vivana said that lab was polished and quick. Yeah, I hope these labs look good to you. By the way, guys, like that's how easy it is to set up Grafana. So if any of you guys are ever like, man, everybody's always talking about Grafana and there's like this whole cult of Grafana. It's easy. That's how easy it was to set up. We just set it up. I talked more. It's been 26 minutes because we got 34 minutes left in an hour lab. So it's been 26 minutes and I've been talking more than half of it. So you could probably get Grafana stood up as a reasonable proof of concept in a system in under 15 minutes. And by the way, here's a fun fact. I tell you guys this all the time. If you go to my labs, right? If you go to these labs in Killer Coda that me and the ProLug happen to put together, and all that stuff is useful to you, and you just throw it in a sack and take it to work and become a rock star with it, I don't care. Take it. It's, use it. I couldn't stop you anyways if I wanted to, what I don't. And two, just go do it. Understand, grok the thing, right? Grok is this term for understanding a thing. Understand how this stuff works and then go and use it, right? Go forth and conquer with these engineering skills that you're learning and make your admin and transition to engineering life easier. And I think that a lot of you guys will find that this stuff is very attainable for you. I mean, look, I've been writing notes as we go, and there's all this stuff that just kind of fits into these different labs we've been doing. By the way, guys, if you didn't know, Sundays I try to do labs. I try to do labs on Sundays. I try to make this stuff valuable to you guys in a way that we're doing discrete individual tasks, but we're also trying to tie them back to like what an admin would want to know. Because an admin wants to know, is my tool up? Is my system running the way that I expect it to? All right, here's what I'm gonna do, guys. I'm still on my. Let me put it back in studio mode. Let me go to my camera, turn my camera off for a second, and I'm gonna pull up my little hourglass, and we'll say. Oh, you know what we haven't shown? I haven't shown you guys Ranger Cam today. Where's Ranger Cam? Oh, Ranger's not. But you guys notice I put the angle back. That's the old angle of Ranger Cam, right? So let's say take a quick break. Check on Ranger. So take a quick break, guys. Stretch your legs. I'll give you a little bit of time. Yeah, Alex, hopefully this stuff's useful to you over on the YouTube side. Alex said, I'm sent from heaven. Maybe I'm not that good, but guys, I have been a college professor for 16 years, so I try to show you guys this stuff in a way that is you can chew it up and attain it, right? You can learn this stuff. All right, I'm going to start that over again. 8 minutes. Take a break. Stretch your legs. I'll be back. You guys should be able to see Ranger. Huh. Stephen Vett said best college professor ever. Yeah, I like that. I always tell my wife, she knows not to compliment me on anything because I always tell her it's from Aladdin where Jafar says, "Now, princess, tell me more about myself." Because Jafar's very full of himself. Oh, also, Ranger should have walked back. Ranger's kind of active in his old age. I think he's getting, I don't know if a dog can get dementia, but if you guys saw him walk over to his bed and then walk away, he's like easily distracted. He gets very confused. He kind of wanders, not quite in circles, but he does the same thing over and over again. So I'm kind of a little worried about him. Yeah, I'm a little worried about Ranger. I mean, he's getting old. We got a new bed though for him, so when the new bed gets here, yeah, Chris, I'm pretty sure I've read stuff about that. Yeah, and it looks like Enzo Bear's done some stuff with that. Yeah, Ranger doesn't get agitated, but he definitely gets confused. It seems, and he does the same thing over and over. So. But when we get his other bed, so I ordered him a bed. These are both pretty nice beds, I think, right? But I ordered him another bed that looks like a couch, and I'm going to set it against this back wall here, and then we're going to push his beds over by it. So then he'll be the king of the beds. He'll have 3 beds on stream, and I think he'll like it. And then we'll move this carpet here that he uses over by it, so he can get up off the beds easier. And then he's just getting old. Like his back legs are weak. He sometimes has a hard time standing up all the way. So he's a good dog though. My wife's cleaning stuff downstairs. She was cleaning out the. She had to look up on YouTube. Had to clean out our washing, our dish, or not our dishwasher, our like washing machine for the clothes. And she was down there like running water through the the clothes washer. So I thought that was kind of funny because like there's like a soap duct. And like you could just fill it with like a whole thing of detergent, but it seems like after 4 years or so, it needs to be cleaned out. So, anyways, that's what I was downstairs talking to the wife right now, and I got myself a drink. So, I put myself back on camera here. You know what I haven't done today though was this. I can answer that for money. I love that. That's the only one I've set up on Streamlabs OBS. So like, I jump between the OBS. I'm not using Streamlabs anymore. I'm all done with them. They kept freezing and breaking stream and stuff, and they'd been doing that shit for like a year. And I'm like, but I'm paying you guys like $10 a month or some crap like that, and then OBS is free. I'm just gonna go use the free and open source one. So that's what I'm doing. Also, this thing's seeing background noise. Well, obviously there's background noise. Hold on. Yeah, better, a little better. All right, let's pull this up here. Got that. Got this. Ranger cam. All right, there we go. All right, we'll give another 48 seconds or so for people to catch up. Enzo Bear said, "What's my thoughts on CCNP? I'm doing my CCNA cert in March and thinking of going for CCNP after." So Enzo, if you love networking, stick with it and do it. I got my CCNA in 2002, and I got into the industry. I got out of the Army. I got in the industry. I started moving computers around. Told you guys I did. I worked at the school district, moved up to a LAN 2. I was in charge of all their wireless and their firewalls, and that's about where my CCNA took me before I kind of just didn't love networking. Like, networking's fine, and I actually teach networking. I teach Cisco. But all the basic stuff, right? I teach all the basic stuff. But CCNP, if you love it, right, and if it's like where you want to take your career, stick with it, because CCNP is great, and then get over into your CCIE. And I've never met a CCIE that's made under 150 a year, right? Like it's a great path if that's what you want to do. And I'm not, again, I'm not trying to shit on anybody's job. I just didn't like networking for me. Like, for me, networks were always just working. And then there was a lot of flurry of activity to get it really right when we changed something. And I didn't like that cadence of things. That wasn't super exciting to me. Because, like, I mostly just sat around and everything worked. And that wasn't, I don't know, it just wasn't great for me. I didn't love it. But if you do like it, I would go get all your certs, absolutely, 100%. So my thoughts on it. And if you're doing CCNA and you really like it, then yeah, I would do that. So again, not trying to crap on anybody's thing, because I think, man, I have some good friends that are database guys. I do not envy doing database work. I have done MySQL. I can do MySQL like to get out of a paper bag, kind of like I can code to get out of a paper bag. But I just can't see myself doing that all the time. Does that kind of make sense? And again, I'm not shitting on databases. I think database is brilliant work. I think most of those guys really earn their money for the stuff they have to do. It's just not for me. Same thing with networking. By the way, I tell you guys all the time this with my college students. Sometimes they get to like third or fourth year of college and they find out they hate networking. And I'm like, God, that was an expensive mistake, because now you hate this and this is what you've been training to do. And this is what you're going to do your career. So I tell people all the time, like, databases make bank, Ruben. Yeah. Databases make real good money. Like, database admins that I know, like, I don't know a guy that works in Oracle that makes under 180 a year. And I'm talking 180,000 a year, right? I don't know a single guy that has that works in Oracle that makes less than that. Like, if they work in Oracle databases for companies, they make good money. So maybe some real junior guy that's not quite specialized in Oracle yet, but once they specialize over in Oracle, they're doing pretty good. So yeah, there's a lot of value in learning how to do stuff, but find your thing that's interesting to you, right? That's why I tell you guys, if you hop on streams and you find, oh man, I could never sit there and just make games, right? Like maybe that's not your thing, and you look at it and you watch somebody do it and you're like, I don't like that. That was pretty free. That was way better than going and finding out after 4 years of college that you hate something. Because I tell my college students this all the time, nobody's going to go like this and throw money at you. You have to be able to do the work still. So, Enzo Bear, you've not decided yet from help desk to data center job, and employees said CCNA. I think CCNAs are great, Enzo. And if you need any study time, let me know. I can't pull up my study stuff here, like on stream, but we can do it down in Discord sometime if you need. And Viavana said can't decide between networking and Linux. Well, if you Here's my thoughts on it. If you go networking, you will do 100% networking. If you do Linux, you will do like 80% Linux and still like 20% networking. So like think about that, because Linux, every single Linux box you're ever going to touch in your career is going to be on a network. I don't think any of you will ever work. Now I might be wrong, but I don't think any of you are ever going to work in a system that is 100% air gapped in such a way that it never touches a network. I don't think those systems really functionally exist. They might exist for some testing, but like my little Raspberry Pis, I set these guys up to just be retro Pis, and they never need to go on a network. But we're not counting that, right? That doesn't really count. I always pull this up as my little example Pi. Let's see, use a Pi 4. Anyways, got a little fan on him. He's my example Pi. I have other Pis sitting around. Well, actually, I took my desk out of here, so I don't even know where all my Pis are. I think they're in my wife's office for a little bit. Yeah, I prefer the system side of things, because systems they're just slightly more interesting to me. But I'm not trying to say anything else is bad. I think you guys should find where you fit. And I often tell people Linux is good because it's such a good base to go jump into all these other things. I might pause it while you're thinking. No, I didn't say pause it. I mean posit. P-O-S-I-T. Whatever. Fucking closed captioning making me look like I don't know how words work. I might argue, let's say, that while you're waiting, while you're looking for different things, do Linux, because then you can branch off into all the other things that are interesting to you. So that would be my thoughts on it, right? I think that you guys can have rewarding Linux work that is also tying you towards networking and these other things. So, all right, let's go back in here. I'm going to back out. It's going to be bright for a second. And we're going to go to our next little monitoring part. So we're going to back out. We did that first part. We did the Loki. And now we're going to do Prometheus and Node Exporter. So this is another one of these tools that I just think is just a great way to do things. Like, I've done a lot of monitoring in my career. I started out with Nagios and RRD tool, and the different ways that we used to do it With Nagios, it was a monolith. Nagios was the front end, it was the collector, it was the aggregator, it was the storage. Nagios was everything in the cluster, and it did everything. When you needed to update any one part of it, you needed to do some checks before you did the update, because you didn't want to take down whatever the system was, because if you took down any one part of it, all of monitoring went down. And I like this, how when we have, so now we have Node Exporter to Prometheus to Grafana here. And if I were to change or upgrade my Prometheus, I wouldn't have to change Node Exporter on my nodes. Node Exporter is just going to simply squeeze up the component of all the system information, and Prometheus is going to scrape that every 10 seconds. If I update my Node Exporter on half my nodes, Prometheus can still, well, within reason, scrape each of those nodes as long as they're following all the rules of the data collection, right? So it allows like a modularity in there. But anyways, this is our next piece. Grafana is going to query from Prometheus Prometheus is a time series database, but it's also a front end. We'll look at that. And then Node Exporter. So let's get this out of the way. Make this a little bigger. Let's do the lab. Your team has determined that they need to monitor telemetry. That means metrics at a distance. Metrics are anything that you want to know about a server. Usage, utilization, saturation, high load, high memory usage, what's affecting the network, all these things. And you can even write your own custom collectors and those kind of things. But you know that Grafana can do the visualization part, so let's install Grafana. By the way, this is the exact same install steps for these 3 labs, so you get really good at putting Grafana on a node, which I think is valuable. Learn how to get Grafana over there. Learn how to figure out how your keys work. Again, you don't need to understand the cryptography of it. Just know that we're downloading the keys separate from Grafana.com, so we can trust them. We're going directly to them. Then we're setting up a repository that when we pull down Grafana, it can test against that key that we pulled separate. And then everything will work, and everything will validate that it was a piece of software that we downloaded that was signed by their key. That's all we're doing there, right? That's what these things are. All right, we get down here. We're going to start up the daemon. We're going to make sure it's running, and then we're going to do that same connection in like we did last time and reset the password. So get Grafana on the system. I love how this thing has no idea what Grafana is. So we're going to start it. And then when we go look, again, for the first 10 seconds or so, it's not listening yet. It's coming up for the first time. It's doing whatever setup it needs to. There we go. It's listening on port 3000. Oh, local Ken, are you one of them DBAs? I just saw I saw it earlier, but I didn't realize what you were saying. But the neither confirm nor deny. Yeah, if you're DBA, you're probably doing all right. And by the way, guys, I think being a DBA is great. I look at some of that and I go, I just couldn't do it, man. I just couldn't sit here in databases all day. I can sit at command line all day, but I can't go one inception level deeper. I can't do it. Right? All right, so let's go look in our dashboard's up. This is our Grafana exposed to the world. Anybody that had this access could get in here. Admin. Don't want to leak passwords because it's all just bullshit anyways. 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8. Those are my very super secure passwords. All right, don't save them. All right, so we've got Grafana up. Good. First piece. We're going to go forward, and it says your team has decided that the data for Prometheus will be exposed via the Node Exporter tool. So the Node Exporter tool is going to squeeze up data on your system. It's going to be, have you ever seen that little stress ball where you squeeze it like this and like the head pops up? That's kind of how I think of Node Exporter. It squeezes up the data, so all your nodes are out there just squeezing data up, and then Prometheus comes along like a little scythe every 10 seconds. Yeah, that was nice. It got that, and it gathers that data, right? We're going to see that Node Exporter is running and exposing on port 9100. That's a common port for it. And I like to make every third-party tool down in opt, so I'm going to make a Node Exporter. We're going to CD in there. We're going to download the most recent Node Exporter, so it's 1.5.0. And then we're going to copy in the exporter service, and then we can go look at that service. This is how we're going to start it. Just going to start it right out of the node exporter directory. Okay. And we should just be able to do a daemon reload and a start. And if that's all working, we should be able to go see that it's running. And then we did a sleep. So there was a little thing we did there. Let me clear the screen up. We made sure it was running here. And we know that it's listening on port 9100 because that's the port it uses. So ss-ntulp grep-i, well, we don't even need the i9100. There's node exporter. But then we did this other thing where we said, go ahead and curl the metrics path. I'm just going to type more in right here. And what'll happen here is you're just going to see that out of that data that was collected here, there are a bunch of key value pairs. Go routines, there's 7 of them. Excuse me. Go info is 1. And we're going to just see a bunch of, in this case, here's go heap in use bytes, and then it's 3.637248 E06. Now, does everybody here remember their scientific notation from school, right? Probably learned it in your lower grades, but then maybe you reaffirmed it in high school. What this is, when you look at this, is anytime you see E06, it's expressed as, you're just going to, it's as easy as this. 1, 2, 3, 4, 5, 6. So really this number could have just been, some big number, but they expressed it as 3.63 whatever. And then when you go to actually present the number, you're going to move that decimal place 6 times to the right. If it was a negative here, it would get smaller and it would move to the left. You guys all remember that, right? I only say that because not everybody looks at engineering stuff all the time. Some people, you forget about stuff. All right. So all that to say, this is your page. This is what's being presented up by the system. All right. So knowing that that's what's being presented up, right? What we should be able to do then is we've got that part done. We're going to go over to Prometheus in the middle, and Prometheus can read that telemetry data from Node Exporter. So we're going to go set it up, and we're going to tell it to pull that data off of that system. So we'll install Prometheus, we'll configure Prometheus to gather telemetry data, and then we'll ensure that Prometheus is running right. So we're going to add the user Prometheus, need him to do this. You can change the way that your system runs and not run it as a user Prometheus. You could run as root if you want. But this is actually good security practice where if the process that's running Prometheus or the web service that it's running ever gets compromised, maybe there's even a vulnerability that gets defined and somebody figures out, hey, I can take over any Prometheus server I can hit that's exposed to the web. Cool. Good job. Good job, bro. But you're only going to be the Prometheus user who's just some simple user, some service user. He doesn't have root privilege. Does that make sense? This is why people tell you not to run services as root. Because if you compromise a service that's running as root, you have root access on the box. But this is just going to be Prometheus. It's minimizing the blast radius of compromising an individual component of a system. We always minimize things more later by jailing them, but we're not doing that right now for this stuff. All right, let's get this. We'll download and run Prometheus. We're going to give some permissions to that directory that we're extracting to. So Prometheus is the owner. And then we're going to go look at our file. Here's our Prometheus YAML. So what are we scraping? Here's our scraping data. And on this local host, we're scraping 9100, which is that node. And then we'll go ahead and copy over our service file. Here's how it's getting started. Here's how Prometheus gets started in our environment right there. User Prometheus, group Prometheus, and it starts the system. Hey, Bottleneck, how's it going? We're not working too hard today. We're just doing some system work and learning how to build out some stuff. So, okay, here's Prometheus running right there. We test it. We see the process running. It's all good. All right. So what have we built? If we step back for a second, I always tell you guys, step back, pick your head up a little bit and say, okay, we've built Grafana. Then we built Node Exporter and validated. And now we built the Prometheus in between, which should be collecting now. And then we should be able to see from the Grafana side of things, the scrape data, right, to get that data out of there. Okay, so let's go look and let's make sure that that's all good. We can access Prometheus right here on our system, and you can actually do commands here like up, and I can just check up and see what systems are being shown as up in my environment. One of the very valuable and powerful things about active monitoring, the way that we do the scrape configs with Prometheus, is Prometheus can now validate, hey, in the last X amount of seconds, that node has been registered, or I see it as up. So there's a very useful kind of up-down system work that you can work with. So, all right, we don't need to look at that right now, though, but we'll go ahead and hit check, move forward, and we've set up all the pieces. So now we're going to take Grafana over to use Prometheus as a data source. We're going to validate that information's coming out of there by looking at a maybe a cool little dashboard 159, and then we're going to see it all work. So here's all the information how to do what I'm going to do. I'm just going to do it over here, and I'm going to say go into connections and just look for Prometheus, right? And that should make sense. We're using Prometheus, so we would look for Prometheus. Now look, there's all these other things. You just need Prometheus. And where is Prometheus coming from? In this case, it's 127.0.0.1 on port 9090. We can call it Prometheus. We could call it Lab Example. This is our name for it, right? That's our own little name. And then down here, if we had authentication or any of these other settings, but we don't have any of that. So we're just going to save and test, and we're going to see that we successfully queried the API. So this is all working. That's all good. So we're going to come down here to dashboards, and we're going to import a dashboard 159. We're going to load it. We're going to say come from that Prometheus data source. We just made that name, so it could be whatever we wanted. And we're going to import, and now we can look at data coming off of that system. Let's not go last hour. Let's go last 15 minutes. Here's data, CPU load, memory distribution, forks, processes. We could drop a little fork bomb on there and watch these shoot up and all this stuff. Now, you got to remember, you're monitoring the same system that you're doing work on. So if we do something to the server, we could very much cause it to slow down. But we could come over here and see that our load average is pretty low here, not really much going on. But we could come back to the box and we could spin up the load average, right? We know how to do that. We could just say apt-y install stress. Get stress on there if we don't have it. And stress is already on there. I'd probably put it on as part of the lab. And I can say stress, real quick, nproc. nproc. We only have one processor. So stress dash C, we'll say pretend there's 4 CPUs. That's bad. And timeout of 180. So we'll do 180 seconds. And pretending that there's 4 CPUs, not just one. So we're going to put the system under quite a bit of load. Stress, did you mean? Oh, it would help if I spelled stress right, guys. I was testing you, and we all failed. Now I come back over here, and oh look, here's the system going under high load. It's refreshing every 30 seconds. I want to make that every 5 seconds. But remember, again, we're refreshing on the node that's under load, so it might be longer than 5 seconds. You'll find interesting behavior in your career around how a system that's under load handles other things that also now are waiting to get access to that processor. So, all right, we're going to watch this shoot up probably into the hundreds. So you're going to see those things that were big, very small. This also starts to talk about scale, right? Because these were just very large, but now they're very small. But the scale we were looking at was only up to like, 0.5 or something. So they looked big. But now the scale is up to 2.5 because this is dynamically scaling. We do not ever, so in CPU usage, see how it's 0 to 100? We don't dynamically scale resources that can run out. So like a percentage of utilization, I would always have 0 to 100%. And if the system sits at empty all the time, I don't care. Or if the system sits like this all the time, I don't care. Because I'm just looking for the delta typically, like when something happens. Look, this system's really starting to spin up. We're going to start to see really high load over time on this box. So, we'll watch it for a few minutes here. This monitoring can be used. Like in my home lab, I have this monitoring set on all my nodes, so I can go look at any one individual node and go, look at how that node has been doing for the last 90 days or whatever. So we can look. There's the data right now of like what's happening in the system. Like, let's say the system spiked and went under heavy load, and we wanted to figure out why. We can go start to investigate that. We can look at historically, does this node always go high? Maybe on a Sunday morning when everybody jumps in for labs, that kind of stuff. Like there's all these things that we can kind of do once we start kind of understanding what's going on with the data. Look, it's starting to go down. It's very possible. Is our time done? Nope, still going. That should still be going up. But maybe it's you know, I don't know why that would be going down like that. That's weird. It should still be going up. Maybe it just hasn't gotten any data for a while, so there's like null data points. No, it hasn't gone up. In general, this should keep going up. Also, there's the 1, the 5, and the 15-minute load average, which also has implications for how long something's been happening when you come to an incident. And you really need to just spend time with those and learn kind of how that works. It takes some time. It takes some time to learn it. But yeah, we can. I would say this system is sufficiently monitored. We can see what's going on with it. We can see that the data are flowing to it. It's not using a lot of memory during this check. It's not doing a lot of forks or processes. It's not doing a whole bunch of network traffic. There's not any more network traffic than maybe normal. Still real low. But we can see the behavior of what's happening on our system. And I'm always talking to you guys about the utilization, what we call the use methodology. And the use methodology is utilization, saturation, and errors of a system. Utilization is between 0 and 100%, how utilizes it. Saturation is as things have to start waiting to get to a resource. And saturation is where let's see. Oh, it's done. Let's do that again, but let's go like, let's say had like 16. Saturation is where you start to have a line form as things are queuing to get to a resource. And then as things start to hit timeouts and fail because they can't get to a resource, then you start to get errors. So utilization, saturation, and errors it's a very good way to look at systems for what's causing the problems. You know, is there a real problem on the system? Do we need to figure out what's going on with it? That kind of stuff. All right, we'll let this spike for a little bit. That's kind of a fun little thing to watch. I think it's fun to watch. Maybe other people don't, but you get used to how your systems behave in the wild, right? As they're actually running around and doing their actual work. So this is a lab environment, so again, we don't care too much about the lab, but we do care about the behaviors, and we do care that our monitoring is working correctly, which it does look like our monitoring is working correctly. We're getting a lot of data from the systems about how they're running. So look, the load average scale just changed there again. Hopefully it'll go even higher here, so you can watch everything compress down even more. Yeah, it's nice when it's real pronounced like that. And you can actually start to see like, hey, yeah, this system is under high load and it's waiting to get, services and processes are waiting to get access time to the processor cores that they need. And that's what we see with the load average. Let's see how it is over here. Still going. Yeah, hopefully that'll get up. It's getting up to 17, 19. And you'll see this dynamically keep scaling, which is, I don't know, it's a mixed bag. When I show stuff, I try to have very defined. Like if I had a high watermark, I might set my load average just above like what my historical high watermark is. So if anything ever goes above it, we can see, and then we can reset the watermark. I don't know of a way to dynamically do that. You could probably write something that would go and dynamically do that. But then you'd be in the same boat. You might as well just turn it on dynamically like this at that point. Let the tool do it. Don't use some third party to do something that's just functionality that you turned off, right? That would be a little bit much, I guess. Yeah. Let's see how. I'm curious how high this goes. I mean, we could really push the box up. We could even do some other stuff that would spin up the CPU. But stress is pretty good. Stress is a pretty good tool for this. Yeah, we should be hitting almost 3 minutes right there. And then we'll see it start to come back down. Yeah, we're almost at 3 minutes. And we'll see it. It hit 26. And then it looks like it's probably starting to top off and come back down. Yep. We're dropping again. We're dropping. So then you might want to think about, why does the 1, the 5, and the 15 minute have different kind of slopes to them? What's the reasoning behind that, and how do we interpret what's happened on the system with that? Right, this is a kind of thing that you want to start thinking about. But again, we're just over here doing the lab. So where's it configured? Most of the time down in opt. Prometheus was down in, we set that up in varlib Prometheus, and you can put that anywhere that you want in your kind of environment. Yep, there we go. Watching it come back down. All right, so we did all that. We can close that down. Let's see. Yeah, that's all done. So we do these monitoring things, and we get these systems set up, and then we determine what we want to see about the data. How are we going to kind of make this data useful to us in the real world, I guess, right? All right, so the next one, the next little monitoring lab, right? There's 3 monitoring labs here. The last one is going to be Telegraph. Telegraph to InfluxDB to Grafana. So while that's loading up, a little bright, I'll pull this up. Now we're still going to use Grafana. We were always using Grafana. And then we're going to use InfluxDB as our time series database. And Telegraph is going to push every 10 seconds over there. Now this is different than Prometheus, where Prometheus was polling. Polling, right? They also use the term poll, Pull, but in the systems engineering side of things, the technical term is you poll. Hey, do you got data for me? Hey, do you have data for me? Hey, do you have data for me? Right? That's Poll. But if you read their documentation, they'll say Pulling the data, because it is polling the data. But you are polling the system. So if you ever wonder like why people use that interchangeably, the systems engineering, like the technical engineering term, is to poll something, Poll. You are polling the service for if it has some information for you. But anyways, you'll see that, and people use it interchangeably, and it shouldn't bug you too much. You just know why both of them are there, and then go about your day. If it bugs you, you have too much time on your hands. And also you're dealing with being overly pedantic, which, by the way, is a thing that most engineers have. Most engineers are like, if it's not technically correct, it's not correct. So, I mean, whatever. All right, your team is determined. They need to monitor telemetry in your environment. You know that Grafana can do that as a visualization tool, so you plan to deploy it on the server as a daemon. We've said that every time, and this is the same exact set of steps every time for us to get Grafana working. So let's get the tool working. Let's get that first part up. Let's get the key so that we can validate that the software is directly from them. Nobody's modified it in transit. Oh, I went too quick there. So we get the key, then we go look at our repository, and then we go and we download Grafana, and we should get no errors, right? If we get no errors here, then the key and everything was signed properly. We'll go down here, we'll start Grafana, then we'll check to make sure that it's listening on port 3000. Same steps we've done every time, right? Like some of you guys are like, oh, you're doing that again. For somebody that's never done this before, 3 times might be pretty good to help stick it in your head. So it shows right here that it's doing the daemon reload. We're going to do the daemon reload anyways for ourselves. Start it up. You'll look, you'll see that it's not started. Again, the very first time you start Grafana, it takes about 10 seconds. And when that comes up, a few more seconds here. Now it's listening on port 3000, which means that we can go in. We got to do the same song and dance each time. We're going to reset the password. Going to make the password what we want. And this one's going to be admin. And then admin, right? How's it going, Jurgen? Or Jurgon? We're just kind of messing around here and doing some lab stuff. This lab stuff, we put this together. This is all up on Killer Coda. It's all free. Like, you might look at this and go, they really give you all this stuff free? Yeah, they don't charge you anything. They've never charged me. I've been using Killer Coda for probably 2.5 years. I've been building labs out there. They've never charged me anything. Never charged anybody that's used our labs anything. It's just free compute. And you say, well, how do they do it? Well, they're the back end of Killer Shell. And see how these nodes have been up for 2 hours almost? I've noticed when they're under heavy load, the nodes, when they get reset, you'll be getting nodes that are down in like the 30 minutes because they're resetting nodes more often. But when they're kind of like chilling at capacity, you'll get nodes up around like 2 hours because nobody's been using the nodes. So like, I would say on Sunday mornings or Sunday, whatever time it is for you guys, you're going to find that they're longer up times and they're just a lot of free compute, man. We're just using it to test our skills and do some Linux, right? So did I set the admin password good? Okay. This system checks to make sure that Grafana is running. That's what our little check does here. So now it says your team has decided the data will be collected by Telegraph and sent over to aggregation to InfluxDB version 2.7. So we're going to go install that version of InfluxDB. So look, we're going to download the repo. We're going to take their key. This is the key that you can get from them. And then you're going to put that key as a trusted GPG key. This comes directly from them. You can go look in their documentation if you want, and you can go grab that. But that's the key that comes off of their webpage for their repos. So I'm going to now use that to install InfluxDB, which is just a different time series database that you can run in your environment. And 2.7 allows you, I think they may even be going to 3 soon, but 2.7 allows you to use a thing called Flux, and that's a query language that they have. So all right, so now we've installed it. So we're going to turn it on and make sure it's enabled. And then we're going to go listen and see InfluxDB is running on port 8086. That's the port that it uses, and that's just fine. It doesn't conflict with most things that you might work with. It's configurable. You can change it if you want. But now we're going to go change. We're going to go do something real quick here. Oh, it's a little bright, but we're going to go into InfluxDB here. And on our first setup, we're going to make a set of users and all that stuff. So down here, it says you can right-click and open this in a new tab. And then it's we could do user lab test. So user lab test. So I'm going to go here and I'm going to say user. And we'll make the password real easy. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And then lab and test. Now before I go forward, I'm going to make sure that that's what I expect. The lab test user. Okay, good. Now, they give me, right here, they give me a key. And I'm going to want to grab that key. Just so I have it. Right? And then now I can just leave that open. I can just leave that open over here and I can go back here. That part's good. So now we're going to go to Telegraph. And Telegraph pushes data, right, to actually Telegraph can ingest a lot of data. It can do processing and aggregation, and then it can also do output. So there's 4 things it does, even though it's still just input, process, output, right? But process can also be aggregation. And now it's going to send it off to that InfluxDB. So let's go look at that. Same thing as before, but you already have that, so you really didn't need to do that step again. And then we're going to install Telegraph. And then we're going to go and we're going to modify a few things to get Telegraph working the way that we want. So let me show you guys how Telegraph works if you've never used it before. Service is up. We're going to go make sure the service is doing things. We don't care that the service is up yet because we're going to have to restart it, but let's just go check. System CTL, system status, Telegraph. It's running. Now let's go VI etc Telegraph. And in here, there's a bunch of global things that you can change and agents and things that are commented out and all that kind of stuff. And then you get down here, after you do some agent stuff, you get to the, here's some, secret store, whatever different plugins you're using. But we're not using any of those. We're not doing any of these other things. So what I'm going to do is I'm going to say /influx DB. And here's an output plugin to use InfluxDB version 2. Do you guys see that right here? I'm going to uncomment that line. So down here they show in our lab, what I've put together, there are 5 things you're going to uncomment. 1, 2, 3, 4, 5. All right. So that changes. The URL right here changes. It gets uncommented. Local address doesn't change. We're going to do the token. And the token can't remain empty. We're going to use this token right here. Oh, damn it. Oh, it's already copied. Control-Shift-V. And it'll paste it in there. Good. Now we need to fix the organization. And if I can't remember what the organization is, this is why I kept this open. Right here. Organization is lab and the bucket is test. So this is lab and bucket is test. Right? So that's all of our data. Now, oh. What happened here? Got to turn that thing off. I don't know. Oh, for money. Okay. Get out of there. All right. That thing, I don't know when I turned that on, if it was recently, but here we go. InfluxDB, that, token, organization, bucket. Those are all the things you need to fix. Okay? Make sure they're right with whatever you'd put in Influx or nothing's going to talk. All right. Now, if that worked, we've still got to restart. Oh, it was while I was copying. Yeah, that's funny. Systemctl, restart Telegraph. And then we can look and see that Telegraph's running. If Telegraph didn't give us an error, we're good. But if I do a status real quick on Telegraph, I like to do the --no pager -L. And we'll see it wrap now. And right here I'll see that I called... These are all the normal things that were there, some plugins and stuff. But right down here, I should see... Where's he at? Yeah, here we go. We're calling the InfluxDB version 2 now. That wasn't happening before because it was commented out, but now we've added that in to the config. And I see no errors, so things look like they're running. All that stuff should be good, so we'll check and we'll move forward. And now we've set up all the pieces. So now we're going to go to Grafana and we're going to verify like Grafana can connect back. So Grafana is going to come over here. We're going to go to connections. Now, you might say, where is this all at? Well, if you go down to solution, here's all the Grafana stuff for how we're going to set this up. All right. And then we want to use, what's the, I don't have a dashboard directly for this one. We're going to make a dashboard as we go. Okay, that's good. So let me move this thing out of the way. Let's go to Grafana. Let's go to InfluxDB. And we got to remember as we add this data source that we are using version 2. So we're using Flux, not the original. That is also mentioned right here. Again, it says make sure you set the language to Flux. The URL is going to be the local URL. HTTP localhost or 127.0.0.1 if you want 8086. That's our port. And then down here for our authentication, we can connect. We don't need to use basic auth. We can use the organization, which was lab test. So lab, there's our token, and test was our default bucket. And then you can set some other things. But if we hit save and test right here, this should read all the way over. Oh, we had an error reading the buckets. Maybe I had something weird in there. Hold on. Control C. Reset. Data source is working, 3 buckets found. So I had something weird that I'd probably accidentally moused over or something. But anyways, data source is working. So we're reading the data source and we're seeing 3 buckets. Now this is where, in this lab only, and it's the third of the labs, so you're the furthest along, that we can create a new dashboard, and we're going to actually go build this ourselves. So let's go over here to Influx Data Source, go here and say dashboard. We're just going to make a new dashboard, and we're just going to add a visualization, and this visualization is going to come from InfluxDB. And then right here we need to write some code, but we don't know the code. You know, unless we're doing InfluxDB and Flux queries, which I don't know how to do all that stuff. So we can come back over here, and this thing will actually help you out. So you say, I want to start out, and I want to read. So here's my, maybe my buckets. And here's my test bucket, right? I want to go look at it. And right here, I can see these measurements that are coming in, right, in my test bucket. And maybe I go to like CPU, and then my CPU can maybe have my usage idle, my usage system, and my usage user. Those are kind of the important 3: usage and user and system, and then idle. And if I submit this, it'll give me a nice little graph here. And this is cool, but again, InfluxDB, this, you probably wouldn't give this to your users. So we can switch over to script editor, and here's the code that we want. So now we can say from bucket test, give me this, and I can come drop this over here. And then now I can actually run the query. Where's it at? You should be able to, not sure exactly where it is, but we'll just save it. Nope, cancel. We'll just say back to dashboard. Nope. Where's that? Edit. That's there. They're supposed to be right here. Typically, you have your run your query. Screw it. We'll just save the dashboard. Boom, save. All right. Now there's the panel starting to get filled with information, and we can come over here. And I was telling you guys earlier, I like to set, when it's a utilization thing, I like to set the soft minimum to 0 and the soft max to 100, because nothing should ever be above or below that, right? And then now if I do that and I come back over here, I can see maybe on just this node, the CPU idle. Let's go ahead and move this in to the last 15 minutes so it's a little easier to see. And I can see that the system is doing whatever it's going to do. Yeah, hey Savar, hopefully this stuff's useful to you. We are just kind of hanging out, and yeah, hopefully this stuff's useful. You know, that's the goal. Watch this real quick. We're going to take this, come back over here to our node, and we're going to do something similar to before. So we're going to say stress. Do we have stress? Yep. And we're going to say, just on this box, we'll say -C. We'll do 16 again, and -T for time of 180. So let's go ahead and stress this box, and then just hang out here and let this refresh every 5 seconds or so, and see, does this actually view, does this actually give, you know, what we expect it to do to this system? Do we actually see, there we go, it just inverted. Yeah, now there's going to be really high user space usage on this. Now this is not load average, this is the usage, right? So we just saw it flip, and then now it's going to be really high user space usage. We could come in here, and while that's sitting there, this is one of the cool things about this. We could just add a new visualization while that's running back there. Come back over here. We're going to go back to the query builder, and we're going to clear this stuff out because we're trying to figure out maybe how this works. So we're going to get rid of that one. And we want, maybe instead of measurement, we want maybe, we want CPU. And we want CPU total. And then we could do that same thing. Where's the, hold on, where's the, we could do devices for disks. Actually, we are going to do disks here. Let's go to disks, and let's go to maybe used, and I like used percent. And if we do this one and we look at this as a query, right? So we submit this. Now we see the utilization of these, like a used percentage. And I'm going to grab that script real quick. Come back over here, and I'm going to drop that in here. And then I'm just going to save, and this panel title can be disk. Right? It's fine, it doesn't really matter. Save it. And we'll go back to our dashboard. So now there's there's the disk, but maybe I want the disk to be underneath that one. So that one's still running high, and then that's our utilization. But this doesn't look good because it's out of 100%. So we need to go do our soft min and max, right? And guys, I'm just showing you stuff that like is like super simple to start, and then you could build on this stuff if this is interesting to you, right? Like I claim no great expertise in this stuff, but here's the use percentage of this. Now we can go back over to our system here, and that thing's still dispatching. So let's go over here and let's just make a file. That's gonna take a little bit because we're abusing this box a little bit. TCP Cowboy, yeah, brings you back to class with me almost 10 years ago. Yeah, some of you guys, I've told you guys I'm a college professor. I've been doing this for 16 years. So as a college professor, I've also been an engineer for almost 22, 23-ish, somewhere in there. So yeah, if people stop in and haven't seen me in a while, yeah, I guess some people have seen me in school, so that's good. DD in file. Let's make this a little bigger so you guys can see it. Let's write to the disk. In file equals, we'll just take dev 0, so we'll just take a bunch of zeros off the system. And then out file is equal to, let's just go in root big file. And then we'll do BS equals 1024K, so it's a 1 meg block. And account is equal to 3000, so it's a 3 gig file. And just for fun, I always like to time these. So we're going to time that, but watch back over here what's going to happen to this. So we're spinning the box up and we're doing all kinds of other crap. But over here, the disk is also going to start to be up because of the utilization. Socio Ectofile. Hopefully this stuff's useful to you. Thanks for coming by. TCP Cowboy, obviously talking, so that's good. Yeah, look, now our disk is starting to fill up. So how high is our disk? What's our utilization on our disk? Now that's going to spin up until that fills all 3 terabyte or 3 gigs that we did, and then there we go. Now it leveled off. So that was our 3 gigs of that file that were just written right there to our disk. We don't care that it's 3 gigs. We care how much of the 100% it's used. Maybe, right? Maybe we do care that it's 3 gigs. People like to see stuff in different ways, and that's going to be for you to outlay as you kind of do this. All right, look, our system here did whatever. Let's real quick, let's make one more 3 gig file, and we'll call it big file 4, and we'll make it 5,000, right? Then we come back over here, and now we expect that to step up by about another 5,000, probably to right about here, right? And this is the kind of thing that you can go and spend time with and get good at. Also, guys, we've got I don't think anybody's done it for a while. We've got Discord over on the Twitch side. That thing pops up every 20 minutes or so. And then on the YouTube side, here you guys go if anybody wants to join. YouTube's always free. YouTube is always free. Discord's always free. And you guys can go hang out down there if you want, talk with other people. We've had some pretty good activity in there lately. But the point is, like, I tell you guys, I could show you all the engineering stuff of how to build all this stuff, but what I want you guys to be able to do is get this to at least a base system in your home lab, and then go run off and do stuff. Like, again, I was telling you guys earlier, one of our guys, Colchis, he built this out and then he automated it, so now he could blow his whole home lab away and come back up, do a little bit of minor tooling on his Ansible, and deploy his monitoring set again. He's just doing all this stuff that we're doing here, right? This is all configuration, all stuff that you can go get good at and mess with, and go forth and conquer and all that good stuff, right? So yeah, here you go. This is it. Now this, again, you might say, and I had people ask, why don't we just show the InfluxDB tool? Well, because this isn't a great tool to give to users. In Grafana, I can build out what I want my users to see, and it's read only. They can only see what I want them to see. They can only have access. This access was I had to have like a key. I had to have my what the hell's it called? It's like my API key or whatever to get in. It's just a hassle to give this stuff to somebody to use as a user. Then they got to go build their own scripts and do their own queries themselves. No. Give a finished product to your and think about who your users are too, right? Like I'm one of my users. My other engineers are a set of users, so that's us. Then we've got maybe our network operations team that we want to see certain stuff about our systems. We want them to see critical failures or high usage and things that they might want to call us out for. And then what do we want to show management and that kind of stuff? Hey, Schizophrenic, we are just hanging out right now working on labs. I'm kind of going through and just adding a little color to the labs for people that hadn't been around for it. And we're just kind of getting through what we can. I'm just putting notes in too as we go. All right, I had two more that I was going to try to get to today, so we'll see if we can get to them. But we are at almost 3 hours. Wow. I imagine some people's brains are melting if they've been trying to go this far. But now we can clean this all up. Look, we only spent about 23 minutes in that lab. You could hang out in that lab and keep building stuff out if you wanted to, right? You could keep playing with the environment. So we're going to go down. We're going to go find our antivirus lab. This lab has a part where it's a good stopping point for you guys. So if you guys have never been in our general labs, here's our general labs. They're out in Killer Coda. They're free. I always emphasize the free part because you could literally just be in a command line right now for free. And that's big, man. I tell you guys, when I started, and some of you guys that have been around know this, when you started in Linux, they just threw you a CD. You know, back in the day, they threw you a CD. It wasn't even DVDs yet. It was still CD. And they said, install it. If you couldn't install it, you couldn't be a Linux guy. That's all there was to it. Go back to doing something else, I guess. But nowadays, there's so many more vehicles and avenues to learn this. The install isn't the only part anymore, right? The install isn't the... All right, so let's go to Clam Antivirus. You can always ask me questions, Savar. I will answer if I can. All right, so here is the Linux lab for you guys that we're doing next. This is antivirus. We're going to install a tool on here, and then we're going to see it works. What do you think about Crunchbang Plus? I don't even know what that is. Is that I don't know what that is. Never used it. It's Debian based, okay. High customizable, modern, full feature GNU system without sacrifice. It's great. It's probably great. Here's my thing, Savar, and I think this is probably a great tool. And I will tell people this: if you've never done a single bit of Linux in your life, any Linux is better than none if you want to be a hobbyist. Now, infinitely hackable, ease of use, good. I think this is great. I think there's nothing wrong with any of this. But what I tell people is when you want to get into doing systems work for like a company, you've got to start focusing on the things that companies are using. So again, if you're at zero in Linux, if you're zero, and what I mean is nobody's doing any Linux, never even touched the command line, get into it, start doing something. I would also tell you go to Killer Coda and do something. This is for in general to people, not just at USA. And then what I would tell you from there is, as you get in experience and use this tool and think, okay, this is cool. I understand how to move around in the Linux shell. I understand the kernel. I understand these things. Then I would tell you, go start spending your time. As you're moving from a hobbyist to a pro, start spending your time in the types of operating systems like Red Hat and Ubuntu and SLES that companies are using. Because I tell people all the time, like, Arch Linux is great. There's nothing wrong with Arch Linux for hobbyists. But I've never run into a company that runs Arch Linux. So if you tell me you want to go from a hobbyist to a pro, and you're like, Scott, why isn't anybody hiring me? I got Arch all over my resume. And I'll say, because nobody's using Arch. And I'm not trying to be a dick to people. I'm not trying to say this is bad. This is perfectly fine. It's got you in a command line. That's the first part of it. You got to get over that hurdle of knowing how to do some command line stuff, right? But then you have to eventually move into the stuff. Look, alternatively, you could, you know, run a company that does consulting for this stuff and get people into it, sure, but that's a tough road to hoe right there, right? That's kind of, you know, making square wheels on your cart and making everything harder. I would tell people, go find, you know, if you want to do admin work, if you want to do engineering work, find the stuff that people are using. So I don't know, I've never used this before or whatever. I bet this is a great tool. I just, eventually you'll have to move away from it, just so you know. That's my thoughts on it. No, you know, I'm not crapping on anybody's distro of Linux. Like I tell people all the time, people always ask me about NixOS. NixOS is pretty cool. NixOS, yeah, it's a pretty cool tool. I just haven't seen anybody using it yet in the industry. Maybe you know, one day I'll be the guy that goes and does that bleeding edge stuff at the front of things, but that's not really what I do. I kind of, if you ever look at the technology adoption curve, right? You guys ever look at the technology adoption curve? You can be wherever you want along this curve, right? Right? Who cares? There's this, you know, the innovators and the early adopters and the early majority and late majority. You can be over here if that's what you guys want to do, right? But if you're trying to get into the industry and you're trying to get your application against a pool of people who will hire you, you're probably going to want to be back here if you're playing a numbers game. Yeah, FreeBSD and Dragonfly are the same way. They're probably great tools. If it's your first OS that gets you into Linux, do it. But I've never seen FreeBSD or Dragonfly used professionally, so you got to move away from them. You can still use them in your home lab, guys. Like, I have crap going on in my home lab here that, like, what do I have going on in here? Hold on. I deleted some the other day. I still got Nagios running in my home lab, guys. I don't use Nagios professionally. I haven't used Nagios professionally in a long time. I still like using it. It's still up on Ranger Cam. Where's Ranger Cam anyways? How's he doing? But anyways, there's this chasm, and there's a thing called the technology adoption curve. Hold on, how's Ranger doing? How is Ranger doing? We're going to get the Ranger Cam back up. That's worrisome. What's going on here? Oh, he's not. My wife must be downstairs somewhere. He's probably following her around. All right, let's do some links. So we're on antivirus. And it says your team has determined they need to run an antivirus program on your servers. This satisfies the PCI DSS requirement that your security team has identified. Okay, so somebody came to you, right? Some team outside of your team and said, we need to run antivirus of some type on our system. Now, a very common one nowadays is like Falcon Sensor, which is CrowdStrike. But maybe your company's a little cheaper, doesn't have the budget for that. So we can use Clam Antivirus. So we're just going to go ahead and install antivirus on our system. We're going to make sure our system is updated and that we have all of the newest information. And we're going to go install Clam AV and the Clam AV daemon on our system. So it's part of our default packages. And you say, how do you know it's part of our default packages? Well, I didn't install any other repositories and it still found it. So that works. And so is it installed? So you would do like dpkg-l grep-i for, in this case, Clam AV, and you would see if it's there. You can also do systemctl status Clam AV, see if it's there. Let's do that here real quick. You could also do which Clam AV. So is it there? Clam scan is there, so is fresh clam. So our tool is there. Yeah, that CrowdStrike thing really got some people for sure. I have many good friends that were texting me day and night for like the first few days after that, where they were just like stuck. They didn't even leave their data centers getting nodes back up and online and stuff. So many of you probably think, oh, that just took down all those Windows boxes. No, it affected a lot of voice over IP people. I had friends that are in voice over IP. I have friends that still do Windows. I still allow them to be friends, even though we're Linux here. Like we're Linux engineering here, anyways. So, but anyways, where I'm going with that is they were calling me and texting me, like they were just working in their data centers for like days straight. So, anyways, all right. So we can check to see if it's there now. So we've got ClamAV installed on our system. We got it running. It's not really doing anything yet, but let's go forward. And it says you have ClamAV in support of your team's PCI DSS directive by security. Good. You know that antivirus works based on signatures, so let's update the signature database and verify it by that the scanning engine works properly. I'm happy I left a CrowdStrike company for a real org. Let's go check. So let's come down here and let's see that ClamAV has fresh clam, and that is running on the system to keep the service updated. So we're going to go ahead and stop that service so that we can manually do an update. If you try to do this update right here, fresh clam, while the ClamAV fresh clam is running, the service, it'll tell you, hey, you can't update because something's already doing updates. But we want to just like do a manual update and see it happen. Like this is us as engineers wanting to touch our tools and go, oh, okay, I understand how that tool works. So we're going to run it. And it says like we're up to date. We've got a daily CVD database that's up to date, and it's got 2 million something signatures. And then there's a main database that's also up to date, and that one's got about 6.6 million signatures. And then they've got this bytecode one, and that one's got about 86 signatures. I don't think that one's been updated in a while, but they are updated as of right now in our system. So those are downloaded right now. So if somebody were to say, hey Scott, in the free Clam antivirus tool that you just downloaded from your repository, and then you've now verified is running, do you have the most recent version of the databases that can be downloaded? And I would say to the minute, I'm pretty confident that we have the most updated version that Cisco is giving out with ClamAV. And you say, Cisco? Yeah, if you go to the ClamAV website and go to the very bottom, they got bought by Cisco back somewhere before 2018. So is it running? You can do systemctl status and then name of service. And this scanner is not necessarily running, but in this case it's fresh clam updater is running, and it has updated even to the minute. We can go look at where things are configured here in a minute, but let's go ahead and say we'll go ahead and enable it and turn it back on. So that's good. And then let's just run a real quick check against, so we'll run time against clam scan. We'll remove anything infected. So we'll look for infected, we'll remove. We'll recursively go down into the Etsy directory. Etsy has about 1,100 files in it, I think. And we'll write out to var log clamav.log. So let's run that. And it's going to go and it's going to scan, and we've timed it ourselves. And then also in the system, we're going to allow it to time and tell us how long it took to do its little scan. I think this is about 15 to 17 seconds or so, if I recall, in this environment. So this is going to go... It's going to scan everything. All right, there it goes. And it took 30 seconds. It took 30 real seconds right here, according to our system. And then in there, it took about 30 real seconds, so that's pretty accurate. It was using those seconds pretty much the whole time doing user system calls against Etsy. Used a few system calls, user calls as opposed to system calls. So it was doing some stuff, and it scanned 765 different files, and it found nothing infected. All right. I want you guys to stop and think for a second. We can sit here, and we can trust that ClamAV works. Right? We can trust that. We can trust that Cisco puts out good code and this open source tool is doing things and finding things. But do we know that that's accurate? Do we know that that actually did anything? Or could it have just sat there for, 30 seconds and said, I'm good. Nothing there. Nothing there. Good. Looks good. Right? Anybody ever remember the first Pitch Black movie? The first time you ever saw Riddick? It was in '99 when that came out. That's an old movie now, right? And he looks, the guy says, is it clear? And he looks clear. And the guy starts to go out and an alien comes out and almost kills him. And he goes, I thought you said it was clear. And he said, I said it looks clear. And he goes, well, how does it look now? And he goes, looks clear. Pretty funny little scene, right? Well, anyways, where I'm going with that is, what if the Clam AV is just like Bender, if you remember Bender from Futurama, where he just crumples up all the papers, puts them in, and goes beep boop, and then he just puts the two people together in his matchmaking service. He's not actually doing any processing. Anyways, what I'm saying is, how would you check this, right? Well, you've got this tool out there. It's I forget its name right off. I'm gonna have to go look at its name. Oh, Ranger's back. Ranger's back, guys. Nobody's done a Ranger check in a while because I made them more expensive for channel points. But there's Ranger. Look at that dog. All right, hold on. So what is the name of that file? It's called the Wikipedia Clam antivirus. I forget the name of it. It's EICAR. That's exactly what it is. So it's the EICAR file. I know that's bright. But I'm going to link this to you guys. If anybody... Oops. I don't want to be in shield mode. I just pushed shield mode on my Twitch side of things, which would, like, not let you guys talk or something. I don't know. So anyways, let's go grab this EICAR test real quick. Just grab that link right... That little block right there. And come back over here. And I'm just going to touch... Actually, I'm going to make dir-p... Etsy, find me, don't want that. I'm deep in the file system. Right? And then I'm going to touch down in there. That's pretty far down as far as recursiveness goes. And then we're going to VI that file right here. I'm gonna hit I, Control Shift V. Whoops, nope. I want to go grab that EICAR. This is gonna be bright for a second, guys. Sorry. Grab it, copy, go throw it back in here, paste it. What? Oh, there it is. Yeah. Okay. Right click, paste. All right. Escape :WQ, and then now I'm gonna rerun that scan while we're kind of sitting here. And does it go fine? Like, now we're making sure that it is getting positive tests against that file system. It's not just, we're good. It's not just looks clear. That's not a good answer. Let's see if it actually finds that virus signature, which is the EICAR file is a standard virus signature. You can put that literally anywhere. Like if you're like, man, I think my system, my Norton antivirus on my home, maybe you're running a Mac or something and you want to test it, that EICAR is in every virus database signature. It's a data signature that's always there. It is always there for positive testing. So you can use that. You can use those on your real systems if you want. If you're like, oh man, I don't know how good Falcon Strike works, go throw that on there. If you're like, oh, I don't know if it actually scans that directory, even though we recursively said scan directories and do scan NFS, but we don't know if it's scanning NFS, go drop that in there. That test will always it will always pop on every major antivirus. And all minor ones too, because they all go use that as one of their tests, right? So it's called the EICAR file. And you say, wait a minute, hold on. What if I zip it up? So check this out. They actually have it down here. Did somebody change this? This is different. Hold on. This is the string, but hold on. This page has changed because they used to have all the gzip ones too. So they had all the hash signatures that had this in it. So if you had like a file that was compressed and hashed, and then the system does a hash against it, it would tell you there's an EICAR signature in that if you were to unpackage that. This has changed. This page used to have this, so that's the string though anyways. And you can go you can mess with them all you want. Where is that? This page has changed in the last. Oh, I don't know if you guys ever use Wikipedia. You can go look at old versions of the page. Right, but we're not going to do that right now. Fucking look at Ranger. That's the tiredest guard dog you've ever seen. Look at him. All right. Where are we at? We can go look at the log, and we can see the scans, and we can see that it found something, and it removed it, because that's what we told it to do. We could also have had it quarantine it. We could have done all kinds of other things with it. So where does this get configured? So there's an Etsy. Is there Etsy Clam AV? Yep. And in here are our configs. So where is it configured? Always good to know as an admin. And that is going to be in Etsy Clam AV. And let's go look at what's going on in here. So clamd.conf. And this is a bunch of key value pairs of how this system is going to behave. How is this thing going to scan our system? What do we want to know about what it's kind of doing, right? So I can see it'll scan mail, it'll scan archives. Do we not want it to scan archives because that's going to take too much time? And we have, there's also another thing. Let's see if we don't want it to follow symlinks. That's true, because symlinks can be recursive. You don't want that ever. Follow symlinks? Nope. Does it have, I've actually never checked this. Does it have, this is going to take too long. So we're going to grep NFS from that. Does it have anything for remote? Nope. So some of these different tools can, it does have depth, how far down it's going to go down, max recursion 16. So I could have actually hidden that Etsy thing further than the default of 16 recursions down, and it wouldn't have found my EICAR signature. And then we could go test that, right? We could, this is what we do, right? This is, we see something and we go, can I go outside of what that thing's capable of doing? And then we go and we do that, right? Yeah, it doesn't have the ability to skip. Here's its database directory. That's important to know in case that's not there, or in case there's actually a thing. I've run into a problem with this. So if all of us were doing this, and I've had this happen with my college students before. Actually, no, this was with high school students. So I have a buddy that runs the high school program out in West Mech, and right as I say that, I realized he texted me last week. So I need to. I'm going to go out and talk to his students. I typically go virtual and I talk to his students about doing Linux and getting into Linux sysadmin, because they do all these tasks, but then they don't really know how it applies. So I do kind of the same thing I'm showing with you guys. But anyways, I forgot. We did this one time in the lab, and we found that when we all did this lab right here, this specific lab, Killer Coda is all going out through one link. We found that out. And ClamAV, we did not know this, but they only allow you to download so many bytes of your update. So if you had like 20 nodes and they were all trying to download their updates at the same time, ClamAV would go, you can't do that on the free version. You can only download. Well, hold on. What if only one of our servers did that, and then it had like an NFS share out for the database directory, and then these all just pointed to that, and then they just read the data signatures out of there. And that would be a fine use case for using using that. And you might say, well, hold on, Scott. You told us very early on in the stream when we were doing NFS, you said you don't use databases over NFS. Yeah, I wouldn't do a lot of read-write stuff, but just reading, yeah. I'd read signatures out of a NFS link. That should be fine. You're basically just reading a flat file, right? So I think that would be a perfectly fine way to do it. But the point is, you could download once, and then everybody would have access to the same thing. So this might be an architecture thing for you to think about, right? All right. So anyway, so we're doing this. Where are the logs errors? We wrote the logs by choice to var lib var log clamav and then clamav.log, but we could have went anywhere if we wanted to, and then we could cat that file and just see those things. So we kind of answered all of our antivirus questions. Is it installed? Is it running? Where is it configured? Where are the logs? And then is there a monitoring solution in place? We could set this to report out to, I have it in my home lab reporting out to Telegraph. InfluxDB. We could set it. I'm actually going to write that in my home lab to report out to Loki, because I don't want it going. Hold on. There's Ranger. Dog. Security. In my security and connectivity dashboard, do you guys see how my ClamAV scan doesn't show any data anymore like it used to? This used to always work about a year ago in my environment. We had all my ClamAV stuff. We can still see the Clam antivirus running in my environment. We know it is, but we're not getting the info from it like we used to. I'm going to rewrite that. We'll do it this week for people that want to hang out, people that are hanging out on stream. We'll write it this week where we set up the monitoring, and we'll report out to Loki, and then we'll show that right here. So we'll have this be a Loki data source instead of this old InfluxDB one, and we'll just have it read out the like the output, so you guys can just see that we have a clean environment. And that'll be every day. That'll be kind of fun. I think that'll be a fun one to write. Okay, so let's go because there's a good stopping point here for us to take a little bit of a break. But you've installed and updated your antivirus. Now it's time to make that run on a schedule. Test the script that's found in answers clam scan.sh. So I wrote this a long time ago. So cat answers clam scan. And this was by me, and I originally wrote it back about 4.5 years ago. I wrote this for a company. I was working at a big insurance company, and we had to, because the PCI DSS standards changed, we had to put an antivirus on all of our Linux boxes. So I wrote this, and this is actually the thing that would run on all the nodes, and then they would report back out to us that they were clean for antivirus, right? Or that they would clean for any kind of thing. So what do we do here? We have a daily log file, which is just tagged with today's date. That's what that is. These are definitions of variables. So that's a variable definition of the name of a file. Super easy to do. Then I did something I don't think is super sneaky, but I also had today. This is just a default log file that is kind of like, I just want you to think of this like, this is kind of like a scratch space for today. So this would be like a little notepad. If I had my little notepad out right here, and I was just writing scratch notes as we went, and then when I was done, I could just throw that page away, or I could just write over it the next day. It's like a little Etch-a-Sketch. You go like that, or you shake it, depending on which one you have, and it just goes back to clean, right? So watch this real quick. I go and I run a scan, and I write it to log file. So I write it to today. Then when I'm done, I copy that to the one that's stamped for today. So now I have an immutable, well, it's not really immutable, but for the purposes of this discussion, immutable for today record of what happened. Then I go pull all of the information from today's log file to go send out to a little report, which we just echoed to the screen for this lab. But then every day that we went forward and reran against today's scan, we would go and have a record for each day of what happened. And we would write each time to today's little temp log, and this would just keep getting blasted, and we would always write to the next one. It's almost like we're putting, have you ever seen one of those little things that like goes and it drops like carrots in the ground? It like plants little vegetables or whatever, and it just keeps planting the next one as it drives along. That's kind of what we're doing. Have I written Python to do things like this instead of using Bash? Yeah, Mr. Couture, I have. I was on a team that mostly did Bash and Ansible at the time, and I had moved away. Most of my stuff used to be in Perl. Like if you guys ever see any of my old stuff, it's all Perl. But on this team that I was on, that we had about 8 people, and me and the other senior guy, Jason, we were the Perl guys. Everybody else was kind of younger, and they used Bash and Ansible. We were getting them all on Ansible. So me and Jason kind of were like, well, we'll use Ansible all the time now. So a lot of my stuff, you'll see it done in Ansible or Bash. I wrote this in Bash, so it was supportable by the team. But yeah, we'll do that, Mr. Couture, this week in Python if you guys want. I need to brush off my Python anyways. I don't use it enough. I would say my Python is less than an hour a week worth of work. So I'm not very sharp on that anymore. So I need to get better at it. Well, Mr. Couture, I'll tell you, for people that don't want to... So the question was, what's my opinion of Python instead of Bash? I would tell you, for people that want to live in the Linux world, and that's where you want to stay on platform and engineering stuff like I do, Bash is perfectly fine. Learn yourself some Ansible so you're a little more useful in that space, but you never have to go to Python or any of those other things. Bash is what's controlling the OS, so if you can do that, you're fine. And then I would tell you, follow Sending Grounds. He's one of our guys. Let me see if I can do a shout out for sending grounds. Let me see if that, oh shoot. He might be sending underscore grounds. Yeah, you should follow him because he professionally does that, but he's like a programmer. He does full on like tool building inside of Bash and stuff. So he's very good at that as well. Where I'm going with that though is, but if you want to be like a Linux engineer that also does like data science, like some of you guys know that I'm like an amateur data scientist. I play around in that space. You do need to understand Python and some of those other things because that's pretty much the language of data science right now. Now look, let me back up for a second because I'm also an academic. The academics are going to start throwing stones at me and go, we do it all in R. And I go, yeah. 3% of all data science is done in R, and it's the very, very specialized economics and data science academia type stuff. Sure. But all the rest of the world is using Python for data science. I'm sorry. Go to Kaggle and look at that whenever you want. That's like a data science site. It's all, it's Python. So anyways, I think it's kind of good. Mr. Tour, yeah, you said Bash gets kind of out of hand when the shell script tries to do too much. Absolutely. Yeah, and if people aren't good at forming into functions and making Bash more controlled, yeah, but I mean, you guys got to remember, Bash is an interpreted scripting language. It's not designed to. It's great for running your OS, and it's great for simple, repetitive things. But I tell you guys, when I want to go hit a bunch of servers, I use Ansible because I have the scaffolding that's already built in that I would have to spend a lot of time developing in Bash, and I don't want to do that. Ansible's already there, and it already works well. So, yeah, Mr. Couture, we'll do it in Python because I need to dust off my Python a little bit anyways. So let's go look. So we're going to make this executable. We're going to look at it and see that it's executable, and then we're going to cat it out, and we're going to see all those things that I said. And then we're going to run it, and we're going to run it against the entirety of the system. So this is going to go against the whole system, right? So we're going to just time it. And now I'm going to tell you guys, you should go take a break. If you haven't been hanging out with me too long, feel free to we'll hang out and watch Ranger Cam. I'm going to take a little bit of a break just because so clam scan will take 10, probably at least like 20 minutes almost. Watch Ranger Cam. So we'll just watch Ranger Cam for a little bit. Freaking Ranger. All right. I'm gonna take a little bit of break. I'll be wandering in and out, but if you guys need me for anything, just I don't know. I don't have anybody here that like normally I put Robodom in charge or something, but I'm gonna take a quick break and then we will let the stuff go. And look, that's my guard dog, guys. That's the guy who keeps me and my family safe right there. Look at him. Look how hard he's working. All right, I'll be back. right, has Ranger moved any? Nope. Look at that dog. Fun fact, you guys would probably stay here and hang out with Ranger more than you'd even hang out with me. I think people like Ranger more than me sometimes, but I could be wrong on that. I think Ranger's a real draw here. Look at that dog. All right. A few more minutes. Let's go check that real quick, by the way. That's going to be running, if you guys do that lab with me, that's going to be running for 15 to, I think it's about 17 to 18 minutes normally, but sometimes depending on the processing, it can take longer, like the size of the thing. Plus, we're scanning everything in the environment, so it's the whole hard drive of that system, so it could take a little bit of time. But we'll sit here, enjoy the rest of your break. I won't run off without you guys just yet. We'll just hang out here and keep an eye on Ranger. Maybe while we do that, I'll review some stuff for you guys real quick here. Put that up here. I'll review what we've done so far today. So, for people that missed it, we kind of started off the day just thinking about what an admin needs to know about a service. And we did NFS and we installed NFS, but we needed to know, is it installed? Is it running? Where is it configured? We wanted to know where the logs were. Is there a monitoring solution that we could use to see that it was there? And we just kind of built this out and then looked at it, right? We just did a bunch of looking at NFS. Then we did the same thing with the Apache Lab. Like, is it installed? Is it running? How do we check those things? How do we verify that it's, from remote nodes that it's connected? And what would be the implications of if we could get to it locally, but we couldn't get to it remotely, what could be standing in our way, right? If we're listening, but externally people can't get to it, is there a firewall in the way? Is there something in between the networks that stop us? All those kind of things. So that's kind of like a little bit of a review of what we were doing. And then we went and we added some things and we made individual different ports open, and then we looked at those ports and all that kind of stuff. Yeah, monitoring solution. Yeah, it's a lot of stuff. Then we came down and we did our monitoring and we checked for the name of the tool and we saw if it was running, and then we looked for agents down in Opt, and then we were doing Prometheus, and we set up all of that monitoring stuff. We did 3 different labs on monitoring, guys. We just kept hammering the same thing over and over again for our monitoring labs. And now we're down in antivirus. And is the antivirus installed? Do we have it updated? And is it using the most? Is it running? Is the DB of signatures current? And we looked at this tool, FreshClam, and yes, right? And then we talked a little bit about that. And then now we're running this big, long scan. That's why we went and took a break. But we're running this big, long scan to see if... look at Ranger down there, man. And the scan is going to take... it's running against the entirety of the system, right? We're clam scan RI against everything and writing out to log file. So this is going to run and come out to the screen, but it's going to take about 15 minutes. And we probably got another 10 minutes or so. Even after our break, we're going to have a few minutes. So we're still on our break. I'll pop back up here. Hold on. Where's my camera at? Boom, I'm back. And there's I can answer that for money. All right, anyways. Monitoring user process and disk space is usually one solution, where URL monitoring synthetic transactions are usually another, but we wish for one. Yeah, Raleigh, there's a lot of ways to monitor and track things, and I want to build a lab soon where we do the K3. I kind of want K6. If you guys haven't played with K6, I kind of want to play with that a little bit. I haven't messed with it yet, but it's where's that? I really want to kind of mess with this little tool. I have not played with this yet, but for you guys that want to go mess with it, I want to see how it scales and how it works against what I've kind of always done with like Burp Suite and just my own little load testing stuff, right? I'm curious how this kind of how this works. I've seen how it works, how they're doing it, but I'm just kind of curious to see it kind of run. Like this is their little tool, and how much got through, and then how much load on your system and that stuff. So I do kind of want to mess with this. I think this would be a fun little tool to go ahead and pull information out of and see. So do some automated testing, because some of you guys know when we talk about testing, we're talking about functional testing. Here's our timer. There's our break. Our break's done. We talk about functional testing and non-functional testing, right? And functional testing is it a web server? Is it on port, 80? Is it secured behind, this kind of firewall? Those things are all functional. We can check. And then non-functional testing is like, how does it behave in the wild? How does it behave when the 3001st connection tries to get into it? What happens? 3,000 connections are fine, sure, but what happens when that next one comes in? Is that automatically a 500 error because the server can't take another connection or not? And that's a lot harder to test, but that K6 system seems like it's got some pretty cool little functionality for that. So I'd like to go mess with that. So Raleigh, you said Place Your Work is in the process of replacing 2 monitoring solutions with one. Nice. Yeah, there's some interesting, and there's always interesting stuff. I was part of when we went over, man, and I did not want to go to this tool, but Science Logic, and I never got a good anything out of Science Logic for the whole time I was the platform engineering lead for that insurance company, and they're still running on Science Logic over there, and I'm just like, oh man, I don't know, man. I never got a single thing I wanted out of that. In fact, it was when I first came on in 2016 to lead that team. It was the first project I ever sat in on, and me and the Windows engineering lead, so I was the Linux guy and then he was the Windows guy. We both had like a 500-page thing to fill out about this, 500 question. So it's probably about like 40 pages of like questionnaire for the project, and I talked to him about it. He sat like across the cubicle from me, so he was on the other side of a cubicle wall in a different aisle. But he and I talked about it, and I said, "Hey man, like I'm not trying to compare notes with you or anything, but did you shit on that pretty hard?" And he goes, "Yeah, it was a pretty terrible tool." And I go, "That's what I thought too." And the company still went with it, and I'm telling you, it never provided anything. And then I eventually I became the platform lead, so I was over the Linux and the Windows team. And I had about 5,000 servers, and I literally never got a single thing I wanted out of that tool. So, requirements testing, but you don't, or requirements gathering or requirements testing, but then you don't listen to your engineers. That can be a problem. I mean, we made it work the best we could, and I guess other teams probably got what they wanted out of it, but I know for certain we never did. My team never did. You might have firewalls and load balancers in front of. Oh, 100%. Yeah, Raleigh. There's all kinds of things that can happen. Yeah. And then that's another point too he just made. There's individual stress testing of systems to make sure that the system behaves the way you expect, and then there's end-to-end stress testing of systems to make sure that they behave like you expect under. Look, here's the thing. If you build like if you're like me and you build 10 servers, right? And those 10 servers can all accept 3,000 connections, and when the 3,001st comes along and that breaks everything, so I say okay. So I got 10. That's 30,000 connections I can have on these 3,000 nodes. And then I put a load balancer in front of it, but that load balancer is doing like header inspection or something, and it can only allow 50 new connections a minute or something. And our transaction time is maybe like 5 to 10 minutes average. We would never, ever get anywhere near 30,000 connection load through that load balancer. We would need to do something else with our load balancer. We would need to either scale those up. We would need to go to a non-application layer and maybe down at like a TCP layer where it's fast and it's designed for like quick transactions and maybe TLS termination. And there's all these different considerations for how we build these things out. Yeah. But the IDS can only handle 2. Yeah, Q's right. It's yeah, you can't. By the way, guys, I might have told you about this. So when I worked in satellites, I learned about this thing that I had never even thought of before as an engineer. This was early 2000s. I was working satellites at Lockheed Martin. And I remember that we had these satellites that were up in like medium Earth orbit, and they had been up there for like 20 years. And some of them had lived way longer than they had thought they were going to, in fact. And they had taken thousands, even hundreds of thousands more photos than they thought they were ever going to do, right? Hold on. But newer servers, newer satellites go up to low Earth orbit, and they live in low Earth orbit for between 3 and 7 years, depending on their burn rate to get into their initial orbits, and then how long, then they every few months they readjust and keep them in the proper orbit and all that kind of stuff. And hold on, just so you guys know, there's a whole branch of engineering that's around why would I build a gyroscope for $680,000 to go up in this satellite. This gyroscope can live for 100 years and be perfectly precise for $680,000. But this satellite is going to live at longest 7 years. But I can build a gyroscope for a satellite that can live for 10 years on average and is only $30,000 to build. So why wouldn't I do that? I know that thing. I know 100% for sure that satellite is going to crash down to the atmosphere and burn to pieces in 7 years or less. So why would I pay $680,000 for this when $30,000 would still get me there? And that is like the whole idea of like car warranties and all this. There are all kinds of engineers that are not trying to build the best and the fastest. They are trying to build the cost efficient thing. Isn't that super weird? Like, some of you probably never even thought about that before, but that is a real thing. I'm not shitting on it. It's a real thing. I'm not like saying, oh, that's terrible. I'm just saying there's real branches of engineering and mathematics that deal with failing a component right outside of the warranty space. I actually, so when I was in the Army, I knew a guy who was a reservist and he was a mathematician, and he said a lot of his friends went to work for the auto industry to do that same thing. And I'm like, that makes sense, I guess. But it never really set in until I did it with satellites. And I learned that satellites are not trying to build the best and strongest components. They're not. Why would I send a satellite up that's going to burn up in at most 7 years for hundreds of millions of dollars when I can build the same thing for $50,000? Maybe not $50,000, but my point is it's less. Policy may last for 100 years, so they got to keep that data way longer. They think mainframes do upgrade and store in place so they persist. Yeah. Streaks over Turks and... Yeah. So I actually learned about that, and I had a buddy when I used the number 680,000. I had a buddy who built satellites for, I want to say it was Raytheon or something. It was some competitor to us when I was at Lockheed, and he had this paperweight on his desk. And if you ask him what it was for, it was just a chunk of metal. And it was a mismanufactured part that cost $680,000. So he had a $680,000 piece of junk on his desk. You could just throw it in the trash. There was nothing about that was proprietary or anything. It was just a chunk of metal. It was worth no more than the metal and then the poor amount of cuts and planning that they had put into it. So he just kept it on his desk to remind him of that failed part of the project. And that's where I come up with that number 680. But it's a real thing. So. All right, where are we at? We're back to this. This is still running, so our virus scanner is still running. We're going to do that during the week. We're going to build a little monitoring solution for this. We're going to rebuild it in my home lab so it does the things that I want it to again. Yeah, because it's been too long. I know that the scan is running. I just haven't been checking on it lately, so I need to do that. Let's check on Ranger. The dog has literally not moved. Is he still breathing? Yeah, he's breathing. I can see his ribs moving. I joke, but he's a very old dog. He's very lazy, but he's a good dog, so we love him. Antivirus, and then if we can, we'll get to Slurm. We'll do Slurm because that's a workload manager, and that's a great tool for high performance compute. Some of you will never ever work with it, but if you ever do, you want to be able to install it and get it running at least. I have a lab that I need to put up here on Killer Coda that does the Slurm tooling and then does the database with it. So I need to add that in as well. So, hey, thanks for the follows. Asperox, hopefully I said that name right. But hopefully this stuff's useful to you. Huh, I almost said it. I don't know. Many companies have products. Yeah, insurance, yep. I'm Otku. Hopefully this stuff's useful to you. Octu. And then JJ over on YouTube said, thanks for all the links. Knowledge. Yeah, I'm trying to get you guys to come and do this stuff professionally because I think most of you guys could. Your brother's a Slurm user? Yeah. Yeah, Q, I have been I have done Slurm on and off for 20 years now. And I've also used other tools, LSF, Platform LSF, which is a much more IBM-centered one, whereas Slurm is open and it's by SkedgeMD. And you can use Slurm completely open source if you guys want, but if you want support, you can pay them, which is a nice thing to be able to use it for a government project, because you can go get support from them if you want. This is taken, it says right here 10 to 15 minutes, but I think this is taken, we did a timer for 8 minutes, and then we've been sitting here talking, so, oh, there it is. It was 18 minutes. All right, so it's done. It did the things, and it gave us an output here of, it did 30,563 directories. It did 101,125 files, and then it went and it scanned, and then it had a time of almost 20 minutes, which right there we see. Okay, so now we can come down here and we can check to see if cron's running on this system. Cron is running, that's good. And we can copy answers clam scan into etccron.daily like this. And etccron.daily will run at 3:14 a.m. every morning on a Linux box. But maybe, so it says right here, it'll run there. And then let's say we wanted it to run at 1 a.m. every day though. Well, we could do cron tab. And in here, we're going to use VI, so 2. And hit Shift G to go to the bottom, hit O. And we're going to add in, maybe we could just use this and it would be at the 0 minute of the first hour of the first of every day of the month, of every month, of every day of the week. Right there, boom. Escape colon WQ. So now I have cron running it at 1 a.m. every day. And then also in here, it's also going to run at cron.daily runs at, again, about 3:14 a.m. I don't know, Q. I don't know why it got picked like that. But I think it's configurable. There's an etc cron tab in your system, and you should be able to come in here and define this, and then let's go find it. Systemctl cat cron d cron, and then etc cron. So here's our default cron file, right? And systemctl edit cron service. Just cat that real quick so we can remember that. I got tiny brain. So systemctl edit cron.service. Let's see if we can edit. I've never tried to edit it before. Oh, the heck is this thing? I don't know how to do any of this stuff. Control Shift X. Get out of there. There's an override.conf, and what if I want full? Hold on. Here we go. Exec start user bin cron and any extra ops and sigpipe. I don't know where it's at. Yeah, I was setting the editor to VI so that. Oh, yeah, you're right. Didn't work. Should have been capital. Oh my gosh. I don't know. It's one of those. Systemd seems determined to replace everything Linux. Yeah, it is. It is kind of doing that over time. Why did I? I'm doing something wrong there. I don't care enough to figure it out. But the point is, we have that now set to run. We can see it there, set to run, and then we can do that. Now, I'll show you guys something else that's fun. If we were ever doing this again, and you were like, Scott, don't kick it off. Oh gosh, don't do it. Right? It's gonna take another 18 minutes. And I say, yeah, that's cool. But what's it doing? Right? Like maybe I want to go like maybe I think it's just hung up on something and I don't know, but maybe I'm hoping it's doing something. Watch this. If you guys have never been doing this, we're getting down to the last 9 minutes of this one. So this one is one of those labs that takes longer. Real quick, I can do a PSEF look for clam. There's our clam scan. And here is the process that's scanning for everything in our environment. So I can do LSOF-P on that process. And I can see that it's doing something. But now, watch this real quick. I can put a watch in front of that if I want. And we can just sit here and we can watch it actually. Oh, actually, watch isn't as good. Watch won't work because it's not going to show us the bottom. Let's sleep 3. Done. Now watch what's going to happen. We're going to see the bottom here. And look right here. This is what it's scanning. So it's down in these snap directories. Now it's reading whatever these are. It's down in these. So it's actually telling us what directories it's going and reading through on the system right now, right? And we could sit here and watch this, and if we wanted to. It's going to be 20 minutes anyways, but this will walk through all the system files. Well, all the system files in the second when we did it or whatever. I support a product that does not support systemd, so you set up old school for initd. It's still using systemd and faking the initd. Yeah, that's actually that's something I hated, that transition, moving from when we used to do service to now systemctl, and I kind of, that transition, you'll still see me do the order wrong when I do systemctl status whatever, or systemctl some name and then status. You'll see me do those wrong all the time because I'm used to the old service. But yeah, when we were transitioning over, when we were transitioning over, and then we would have systemd call the script file. It's and you're really using initd in the background, but it's because systemd is controlling everything. I was part of that transition too on some teams, so I've done some of that stuff. It's once you do it though, thankfully most of the startup just works fine. It's just a little bit of extra stuff. Okay. So we did that. We won't let this scan finish because we don't care. But we can close this lab out. So we're going to back out. We're going to go to our last lab last planned lab for today, really. And we're going to do this Slurm stuff. So Slurm is a workload manager for high performance compute. Q, you said some graybeards to type in at 6. You'll see me do that sometimes. You may see that on some of my scripts too. And also I have way more gray on me than I want. It's been really bad the last few years. It's been really coming in. So I get the wife to cut the hair a little shorter so you guys can't see it as much. But yeah. I don't get a lot of beard. No, that was one of those. So there's actually a meme that I love that perfectly discusses this. But I go in the Army at 18. I actually joined the Army at 17. I get in. I don't ship out until 18 though, but I'm 18. I'm shaving every day, and I think when I get out of the Army at 22, after shaving literally every day of my life, that my beard's gonna grow in thick and full, and it just never does. So then this is 21 years later, and still doesn't really come in. Oh yeah, no. I have a buddy who still really dyes his hair as black as night, and it's kind of strange. The first time my wife ever met him, she was like, "What is up with that guy? I can't put my finger on it." I said, "It's his hair," and she goes, "Oh, it is his hair. I didn't know." It's funny because she does hair dyeing for her friends, and she does haircuts and stuff. She's done that stuff for 20 something years. On top of being a help desk person, she does that on the side. And she's got her, license and all that stuff. Or she did at one point anyways. I don't know that it really matters if you keep it. But anyways, where I'm going with that is the wife. She said, oh, yeah, as soon as I saw it, I couldn't unsee it. Because the blackness of this dude's hair is this color right here. It's that black on us in our 40s now. So, hey, but on the plus side, at least my hair's not thinning. And you guys might say, well, but you got pretty thin hair. Yeah, but it's always been like that. My hair's been that way since I was a teenager. So it's not falling out anymore, at least. That's kind of nice. At least I'll still have some hair. into maybe my older years. Yeah. I'm not ever gonna do anything like that with my hair, but I will tell you that it doesn't. My beard doesn't grow in all the way, so that's always sad. Like you get out of the army and you think, oh, I'm gonna grow this big old veteran beard, and you're just not. Nope. So, nope, doesn't work. All right, let's do some Slurm. So Slurm is a couple things. One, he's a joke if you're watching the show Futurama. Slurm McKenzie. He likes to party, but he parties too much, so he hates it. If you guys don't know what I'm talking about, just you're too young for it. But I'll link this to you guys that want it. Haven't shaved since 1981. Wow. That's oh yeah, that'll do it. Slurm's a drink. Yep. Slurm McKenzie. Everybody gets installed. So, let's do the lab. The questions over here on the right, I'll post these up in the notes section of the Discord later if anybody wants them. But it's like, what does an admin need to know about a service? Like, what do we care if we're just some guy in the company? Now, in the labs, we're building everything out because we have to. But then as an admin, what do we need to know? Like, is something installed? Is it running? Is it configured? Where are the logs? Is there monitoring? Like, these are the things that we need to know. Your wife's never seen you without a beard in over 30 years. Oh, wow. Yeah. Don't ever shave. Like, I've seen the videos of, you'd have to probably do it with the grandkids now, but like the kids see the dad without the beard and they just start crying and run away. And because they've never seen their dad without a beard, and that's kind of funny. All right. Now we're talking about proof of concept. Your team wants a proof of concept around scheduling jobs across multiple nodes. So we're going to set up a way to schedule jobs in our environment. This is not going to be super advanced because we don't have a lot of like power in this lab, but we can set up a basic little HPC cluster with Slurm and send some jobs around on it, right? So we're going to install Slurm and have the appropriate daemons running. Slurm needs a couple things to work. Now, a lot of you, if you're a Linux engineer and maybe you've been doing it, let's say you've been a Linux hobbyist, but you haven't been an engineer or an admin yet. When you get up to doing this stuff professionally, which is where we want you guys all to get, you're going to run into stuff where you're like, a design decision was made there and I don't understand it, or I don't know where it came from, but I need to understand it now because I'm supporting it. Slurm uses a tool in the background called Munge. Munge is a daemon, and Munge will run on two boxes, and it will allow communication to happen based on the Munge key. The Munge key has to be the same on both nodes. So we're about to do a couple of installs on two nodes. We're going to make sure that the Munge key is correct so the devices can talk, and then Slurm is going to come in and communicate over the top of them. Now, you might say, and it's M-U-N-G-E, Munge, like to munge something, right? So you guys can understand, like, if you've never seen this before, this is kind of be like a paradigm shift. You're like, but we connect over port 22 and we do SSH, and that's the way we do things around here. Not always, guys. Sometimes a design decision was made somewhere and things happen differently. And this is perfectly acceptable as long as we understand when we support it that if you ever come to a system that is not communicating properly with Slurm, one of the first things you should probably always do is make sure Munge is running. Because Munge and Slurm, they're like peas and carrots. They go... You guys all know... Anyways, all right. Sometimes I think about the design decisions and the answer. I was doing this at 10 a.m. after getting paid. Yeah, that's fair enough. All right, so let's update the system, make sure it's good. And then let's install Slurm on this primary node. He's going to have three things running. He's going to have Slurm. He's going to have the Slurm control daemon. And then he's going to have... Munge is going to get installed with Slurm, so that's fine. Bob Billy, that's a great name. Hi, big fan. Do you think you'll ever do free IPA Red Hat identity management setup with Windows and Active Directory, since a lot of enterprises still want to use Microsoft Active Directory? I thought it was called IDM. Is it not free? Is it not IDM? Is it called free IPA? I know Red Hat has their identity management for free for people. I wasn't ever going to set that up in the lab. I have run that before professionally, but I had thought to set up Keycloak in the lab for people to play with. But no, you're right, Bob Billy. 90-something%, probably even higher, of companies run on Active Directory. So we on the Linux side learn how to build what's called trust relationships with it. And that free IPA, I thought it was called IDM for some reason. That tool can absolutely. Is free IPA the non-Red Hat version? Because I thought Red Hat's version was called IDM. Yeah, it creates trusts, Active Directory. I think free IPA is part of Key. Like, I think Keycloak uses that under the hood. I've never used this directly though, so I'll play with it. Go dark mode so it doesn't kill everybody. I'll check it. I'll check that out. I'll look into it. Yeah, SSSD is pretty good. You know, the problem I've had with SSSD the most is where do you cache? Where's the line? So it's a fine line. Have you guys ever heard like there's nothing hard in systems engineering except for naming and caching or cache expiration there's like 100 ways to tell that little saying, but SSSD is the worst caching problem I've ever come into. And because what happens is if you go into a box often, it will, if you want it to, it will cache your username and password for your users. That sounds cool. It sounds cool until this one thing happens, which is you set it for like 2 days just in case your unreliable Windows network, I was in a place with an unreliable Windows network, is having problems. But then what happens is your system is cached, right? And the user's password is cached on that system. And then the user changes their password over here in Windows. And they try to go into their system and they can't get in anymore, but then they can get in on their old password. But that old password should have cached out. So you say, okay, hold on. I'll go ahead and I'll get rid of caching. Caching is stupid. That's dumb. So now your user sometimes can't get in because the unreliable system that they're using for your trust store is down. Guess who looks bad either way? If you're the Linux admin and you're the Linux engineer that's built all the system, guess who looks bad either way there? Mother effers. Because now the blame, because my system is unavailable. My system's what somebody's trying to get in. So anyways, yeah, that's automated systems cache the creds. Yeah, so that's what I'm saying. Yeah, in this case, SSSD will sometimes cache the creds, and then you'll have this problem. Hold on, did Ranger change positions? Look at that dog. All right. Let's do this lab real quick. So slurmd has been installed, and slurm control daemon on this node that's going to run everything, right? So now we're going to jump over to node 1 and do the same basic thing. We're going to install just slurmd on that guy, though. He doesn't need the control daemon. He's not in charge of anything. But now I want to tell you guys something. I want to explain something that's happened here. We did 2 different installs on 2 different nodes. So this node, control plane, he built his own Munge key. Munge ran and made its own key. And then node 01 also made his own Munge key. Munge isn't going to talk like that. We have to have a way to share the key. And in a lot of systems where we have like big global parallel file systems and Lustre and stuff, we'll put the key in a place where all the nodes can grab it as they come up. But I didn't do that here. I built 2 different nodes with Munge. So now the next thing we do is we copy the Munge key over from the primary node to the other one. This is kind of a stopgap. It's kind of a, what I mean by that is we're doing it in the lab, but we're understanding that this will not be a sustainable 100 node, 1,000 node, 10,000 node system. We're going to have to do something else with this key. But let's acknowledge that, and then we'll just push the key over. We have to restart the service over there. Now Munge is using the same key in both locations, and now Munge and Slurm can talk, right? They can do that. Now, real quick, is it installed? dpkg -L, right? Because we're in Ubuntu system, so we got to use this. On other systems, we would use RPM QA. dpackage-L grep-I for the name of package. Now, we know we need Munge, so same thing, right? Is it running? So psef grep-I for slurm. We can you could be sneaky if you want, or slick Munge and slurm in one go like that. So over here, psef grep-I capital E, and then do slurm and Munge all in one command, right? And I can see now Munge is running, and oh, Slurm is not running on control plane. So did I not start it? Oh, so we'll restart Munge over there. We did that. And then let's look at our Slurm. I'm actually fine with Slurm being off on these nodes because I'm going to copy out my answer slurm.conf, which is the file that I put together, right? Wait, Q, you can't see my screen? What happened? Is my screen down? Oh, I see it. I'm looking at both my sides of things. It looks like things are up. Yeah, Bob Billy, I'll definitely check it out. I haven't played with that tool at all. I'll definitely check it out though. You guys can see me? Okay. Looks like Q lost me, but maybe it'll come back, or one of you guys, maybe Couture. Yeah, somebody. I get errors in streams sometimes when I'm watching streams, and then I have to like reconnect. But that's because I watch a lot of like Dead by Daylight streams. All right, so this is where the system wants to read it. I had never seen that before. I had done it on the Ubuntu. I thought maybe this was just because it was the free and open source version. I've always seen it down just in Etsy Slurm, but they use this LLNL. Just know that that's not the path that I'm used to seeing. And then let's go look at that file. And I want to show you I think it's 5 things I changed in this file from the default. By the way, I also want to show you guys one other thing. If you're doing this, right? If you're going and doing this yourself, you can go to SketchMD. And I think right here, Slurm configuration. They will give you, there's a really awesome Slurm configuration tool when you're down here building it, and it'll build a full Slurm configuration file for you, right? You just tell it what you want, and it'll build it. Look at all these options. There's a tremendous amount of options. I think it's right here at the bottom of this. It's like, do you want me to make one for you, buddy? Where's that? Hold on. And you could literally, you can put in, hold on. Where's that? So this is the Slurm doc, right? You just go to slurm.sketchmd.com, and then, hold on, let me see if I can find it real quick. Installation guide. And they'll give you right here under, so here's how you build it all this stuff. Configuration. I swear this is where we just were. They will give you there's a builder. Hold on. I want to caution you with the builder. The builder is going to do everything very vanilla. And where's he at? Let's show you how to install Munge. Here's the configuration tool. I'm going to show this to you guys, but I'm going to tell you, be real careful. Like, if you were going to do this, make sure you have a backup in your company. Like, don't ever just dump this in somewhere. But you can give a cluster name and the Slurm control daemon host and all these things here. And then when you're done, right? When you're done and you hit submit, it'll build the config file. That's the exact config file you need right there. All right. We're not going to use that though. I don't even recommend using that. I'm just going to tell you that I took the base config file that came with it and I changed these things for the lab for you. We called it Prolug Cluster, Professional Linux Users Group. We called it Control Plane right here for the Slurm control daemon host, right? And then down here at the bottom, hold on, we changed just a few things down here. We made we explicitly gave the node name for Control Plane 01, Control Plane and Node 01. We only gave one CPU, because that's all they have, and we only gave 1,500 megs of RAM. So 1.5 gigs. We didn't use all the RAM, because there'll be problems if you don't have it. And then we made a partition for Prolug. Partitions are kind of like work queues. And once we have this all working, we're going to restart Slurm on this node. And then we're going to, we need to copy it over there. And then we're going to restart Slurm on that node too. All right. Now, if Munge is running, which Munge is running, we should be able to see that Slurm is running here, and Slurm control daemon is running on this node, and he's listening to anybody on 6817. That's the default port, by the way. That is also one. So is it running? You can always do ss-ntulp, grep-i for Slurm, and then we expect to see 6817, right? We expect that, and then that's on the master node. So they're master and worker nodes, or whatever people call things, different things now, but control daemon node or whatever, and then expect on the worker 6817 118 right there. Boom. All right. So now that's set up between the two nodes, right? So we've got these things set up, and it looks like we kind of understand where is it configured. This system's kind of weird. It's in Etsy SSH Etsy Slurm -LL, right? LLNL. That's a little weird to me, but that's where it is. You can change that, right? That's you could just change it back here to Slurm if you wanted, but that's where it is in the lab because that's where it goes by default in the default one that comes with the package manager. Now, could you download Slurm and compile it yourself? Absolutely. You don't have to use a package manager for Slurm. You could download and get a very specific version, which, by the way, is what I do when I do this stuff professionally. I told you guys I build these tables. I build them typically in like OneNote or whatever tool the company wants to use. OneNote is a common one for me because I can just build a table and then dump it wherever I want as a CSV. But it'll be a matrix, and the matrix is here's all of my devices. Here's all their kernels. Here's all their versions of GPFS. Here's all their versions. Well, it's OFED first because OFED is the Mellanox driver for the cards for InfiniBand. So I have all their OFED drivers, then I have all their GPFS, and then I have all their Slurm versions. And all of those things I move forward all together as I'm updating systems. I never move things individually or individual components unless they're down in like a test environment, right? So I'm very like, you guys will find if you ever work with me or if you ever talk to people show up on stream sometimes that have worked with me before. I'm very like controlling as an engineer. And it's not because I want to be controlling. I have to be, right? I'm like Snuffles. I need to be understood. I doubt anybody got that reference, but I need to control the things in my environment, or I can't be responsible for them. So I think it's good engineering to control things. So I forgot where I was even going with that, but the point is I'm kind of crazy. So all right. So where are the logs and errors going? We can go and look at that. So we're back on our system. CD to var log. Is there a Slurm? Ah, there is. And in here, there's a Slurm log and a Slurm control log. And I could just tail-f on Slurm control log. Right? And I could just make sure that things are doing what I expect them to. And I could also do it on just the Slurm .log. Where's that other one? Right? And then I could just make sure that my system is doing the things that I expect it to, right? So where are the logs and errors at? They are down here in var log slurm LLNL, which is, not maybe even the way that we want to do it, but we can at least see it. All right, now we can do S control. So now we're on this control plane box, and we can look at a whole bunch of information about our system here. And we could go, if we wanted to, we could just look for the log configs. Here's where all the logging information in our system is going to happen. So some things are not happening down in this var log. If you were to tell me, hey, where is accounting happening? That's happening over in var log slurm account job. So that's just happening down in var log. That's not happening down in var log slurm, right? Could I change it? Absolutely. We can change anything we want, but that's part of our configuration file. Now we'd have to reload everything, right? All right, so we see that. We go, where are your logs writing? Why might this information be useful to you as administrator? So this is an important thing to stop and think about. We know where something's installed. We know that it's running. We know where it's configured. But in the wild, right, as things are running and existing and doing whatever Linuxy things they're doing, this is a workflow manager that we expect to behave a certain way. If things are not behaving the way that they should be, hopefully, yelling in their log files the problems they're having so we can go fix their problems. This is the one thing that I used to say because people used to ask me, like, what do you do on a daily basis? And I'm like, if you ask me that as a manager, I can't tell you what I'm going to be doing today. I mean, I can tell you what my project work is, and I might be fumbling around trying to figure out some stuff, but my day-to-day tasks on like keeping stuff operational, I have no idea what's going to be called of me. So I need to go look at logs and see what's happening to these systems. The system's over here in the dark, not able to talk to any other nodes. What's going on with it? Why can't it communicate? And at the end of the day, it should be telling me in the logs, and if it's not, probably munge. It's always Munge, guys. It's always Munge. It's not always Munge, but Munge will cause you headaches if you don't get that part of your Slurm builds right. Anyway, so this is the thing to know, and then we can go look at sinfo-n, and we can see that we've got these two nodes, and they're in this partition prolog, and they're both sitting idle. What do you use for log viewing tool? Well, in this, it depends what I'm doing with logs, right? Like if I'm trying to see errors in logs, I'll just, and like maybe I'm getting an error behavior when I try to start slurmd, I'll just tail-f the log in one window, and then I'll just start the service, and I'll see what yells. Other than that, I mostly grep things, and I look for errors. I look for, like if I know the name of the system that it's trying to connect to, I'll look for that in there and see if I get any kind of understanding of what's going on in the system. But mostly for log viewing, I'm either sending stuff off, and then I'm pulling it up in like Loki or Grafana, or sometimes I do it inside of, what's that really expensive tool? I only do this if the customer has it. It's the one where you throw all your money in the pit. What's that called? Why can't I think of that? I cannot think of it right now. Splunk. Yeah, Splunk. If we have Splunk, I'll use Splunk too. But I'm not great at crafting Splunk stuff. So I'll, whatever. But mostly, like if I'm in the thick of it, it's tail and grep. Tail and grep will do most of the things. Datadog's good too, yeah. Datadog. I've never used Datadog professionally, but I have set it up for like test clusters and stuff. AWS, you can send stuff to AWS logging if you wanted to, for sure. No, I was thinking Splunk. Splunk's the one where you just throw your money in a pit. Their logo should just be a big hole with you throwing money in it, or your company throwing money in it. So, all right. So where are the errors? Right, boom. And then if there were errors, we'd maybe see them down here, but we don't have any errors, so we're good. We're confident that the cluster's running properly right now. I'm sure with Datadog. I've mostly done some proof of concepts with Datadog deploys, but mostly we use New Relic at one of our places. So New Relic is kind of one of the competitors to them. But I remember doing some test deploys with Ansible. Most of my deploy stuff, like you'll see my Ansible, like I do very simple things with Ansible. Push your little executable, your installer, install it, verify that it's there, and then push the config file and start it, or whatever the things are. And I've had to do that with Datadog, New Relic, when we were testing them out in our environment before. All right, so anyway, we come down here, and what's our next part? It's time to run some jobs on the cluster. So let's run a simple job against one node. Let's just do an srun. Srun is a interactive, sorry, not interactive. What is that called? Srun will wait for as long as it needs to for that one node. What's that? That's synchronous. So synchronous means I'll wait until the response comes back. Async is I'll just lodge it off and then I'll wait. I won't wait for it to come back. I'll go do other things, right? So this is a synchronous call against the system. Let me prove that to you here. We're going to run it again, and against 2 nodes, it's going to get 2. But then we're going to do a synchronous call against 10 hosts, right? I said go against 10 nodes and give me their host names. And it'll queue it until 10 come available, and it'll sit here forever just stuck. That's what a sync as opposed to an async process will do. Some of you guys have done sync and async in like your what are they called, like API calls and stuff. You'll learn about sync and asynchronous, and then when you do queues, you'll learn about short and long polling. Well, this is the same, a synchronous call. It's waiting now forever. So I'm gonna have to Control-C this and stop it, right? Because we're never going to have 10 nodes available. So that was never going to be able to run against 10 nodes to give me their host names. So that seems really simple, but that's an important behavior to understand as you're deploying things and training your users if you're the admin of like a Splunk type system, right? Then we come down here and I say, wait a minute, I have this script here. So cat root submit.sh. And this is written in a Slurm batch format. So this is the way that Slurm wants to look at a batch for submitting jobs. So we're going to submit a job. We're going to give it a job name of test. We're going to give it an output place. So now it's going to put an output to root result.txt. The partition it wants to run against is that prolog one that we saw down in our configs earlier. We're going to give it a time of 10 minutes. It's got 10 minutes before it fails. And if it fails out, it's done. We're going to give it one task so it can go to one node. And the CPUs per task is 1. So we could send it to one node and give it multiple CPUs, but we only have one CPU, so that's all we're going to do. And we can also allocate up to 1,500 bits of memory, right? Bytes of memory, technically, per CPU, because we have 1,500 set in the system, right? When we did our sinfo, right? That showed us, oh, it's not even shown there. But sinfo by itself will show that we have these two nodes, and then it's down in the, if you did like a tail -5 on etc slurm, you would see that they're 1,500 memory allocated. So if they had more CPUs, we could be running multiple jobs and they could be sharing those nodes, or we can actually write it where nodes get locked, where they don't get affected by anything else. You start to get into capacity planning issues when you do that, because then if a user ever locks in like 60 nodes and you've got like an 80 node cluster, they may be hard. I've had people doing like watch commands inside of their batch shells, and those nodes are sitting completely idle, but they've locked half a cluster. So now you got to go back and you have to like, well, we can't allocate that because people will lock the nodes and then they'll be using literally 0 CPU on them. And then your cluster, you'll be looking at all your cluster stats and you just won't be doing anything. Actually, speaking of that, we need to get, I need to do some more labs with this, because then I want to do my Grafana and show you guys how to do the other Prometheus, the node. So there's a Slurm exporter to Prometheus, and then we can go look at all the Slurm jobs in the dashboard too. And then that's another way to feed information out to, again, I tell you guys, there's basically like 3 ways I think of like the information in graphs. I want to see it for my team. I want to see it for like my network operations team, my alerting when my team is asleep, right? Like our 24-hour team. And then for our management, like what do we want to show managers, right? Because they care about like capacity planning and that kind of stuff. All right. So anyways, we're going to do an S batch to run that. And then we're going to look at the queue. So there's a queue for that tool running, and I can actually run SQ a few more times. And I'll see that it's taken 9 seconds now, that job that's running. But what's that job going to do? It's going to sit there, it's going to do a host name, and then it's going to sleep for 60 seconds. So that job's going to take 60 seconds to run, to finish, because sleep is a real job. It's a real process. So he's at 27. He's almost done. He's going to be done here by the time I can do, like, by the time pretty much this is done, he's going to be done. Where he'll be right at like the end of his time. He has 10 minutes to run, but he's going to take about a minute to run. That's what we know from that. So let him run. He'll be almost done when this kicks off. Yep, he's at 52. So wait a few more seconds. He's at 56. He's almost done. We're going to see him disappear here in a second. And there he is. He's gone because he's finished. And then if we go re-look at that, go look at it, it wrote out to root result.txt. The one output from that system was the control plane output. And the control plane was the node that just ran on in our system. So that's not super impressive. Like what we did there doesn't probably seem super impressive, but this starts to be the basics of installing a job scheduler, and then you can go off and look at, well, what would we do to like run a Python job against both of these? And then what would be our problems with if we're not sharing storage? Well, if you're not sharing storage, then one of the nodes isn't going to be able to write. So now you got to figure out how to get shared storage with NFS. Isn't really great, but maybe you have a little bit faster options with like maybe a Lustre, like a parallel file system. Maybe you can people will use Ceph. That's more of an object store, but you can mount it. primary ones that we use are Lustre, GPFS, and actually one that's really been up and coming that I've been using a lot is Weka. Weka is a super high-speed file system that's pretty interesting. They've got some interesting components of that, and I keep thinking they're owned by Dell, but because we work on a team mostly with Dell and Weka, and that's my portion of what I've been doing lately, the last year or so. Maybe not quite a year I've been doing that, but there's a significant amount of Weka as our high-speed parallel file system for everybody. So everything needs to be connected into the same spot. Anyways, all right. Monitoring solution. There is a Prometheus exporter for Slurm. Need to build a lab so we can see it. There's also database. You can have accounting database, and I need to finish that lab because I set that lab up and then I just never finished it. I probably set that lab up like probably almost a year ago, and I never finished building it all the way out. So that's kind of that. So real quick, one last little review of all the things we've done. Right, we came in, we did our NFS stuff to start, we did our Apache stuff next, then we did some monitoring. We did 3 different labs on monitoring. We did an antivirus lab, and now we've done the Slurm lab to just kind of look at things we might run into, things we might support in our, like, I tried to look at these from like a systems administrator standpoint, although we were also building them, so some of the stuff was what we would rightly call engineering because we're building it out. And when we were doing that, you might have said like, hey Scott, I don't agree with that decision you made. And I'd say that's fine. Like in the lab, blow it away and do it the other way. But this is the thing where it's like we have to understand as we engineer and design things, like what the implications are of the different decisions that we make. Like what's the implication of choosing, this, or what's the implication of choosing this, and what does it do to our system? And then really after that, there's 2 ways to learn that. You can learn it in the School of Hard Knocks, or you can learn it by going and reading about it. But there's not a lot of publications on Slurm. There's a lot of publications for use on Slurm by different colleges, like you'll find those out there. But if you want to be like an admin on it, you really just have to kind of build it and play with it and mess with it. So, all right, how's Ranger doing? That dog. What do I pay him for? What do we even pay for around here? All right, we'll leave free IPA up. What do I need to do? I'll probably get off of here soon. We'll go raid somebody out and have some fun with that on the Twitch side of things. But we've got a professional Linux users group. I always try to tell you guys about it. It is a free bunch of engineers you can go hang out with. I think there's about 3,500 of us now or so, last I checked. And you guys are welcome to hang out in there and ask questions and talk shop. People just kind of drop stuff in there that they're reading about or hearing about in their different parts of the industry. It's a pretty good little pulse on like understanding what's going on in the system. So I tell you guys to spend some time there. If you just want to, maybe you're a Linux engineer and you want to get off into some other space. We got guys down there doing ML stuff and AI type stuff and getting certs in it in like especially the AWS space. There's some certifications out there that some of you guys are working on. So all right, let's go raid somebody. Let's go find what's going on here. Let's go to our little end of stream thing. I definitely appreciate everybody coming by. Let's see if there's anybody on. Maybe Rob's on. We go right over to Rob. I don't see Rob on, but I do see Practical NPC. So we're going to raid Practical. If you guys don't know Practical, he does a bunch of game stuff. It's pretty good. Our raid message over there will be do all the Linux, if you guys have that message. And I definitely appreciate you guys all coming by, and I will see some of you later on this next week. All right, take care.